Hi, welcome back and congratulations on taking your next step into Houdini. Today, we're continuing our beginner series and extending on the foundation we set in Lesson 1. By the end of this video, you'll have a fundamental understanding of how materials work in Houdini and how to create and leverage materials in an efficient and practical way to use in your own projects. We'll cover the fundamentals of material parameters, learn how to incorporate geometry attributes into our materials, and also learn some practical tips on setting up reusable networks for these materials. We'll cover workflows on setting up various lighting setups in a single network, multiple material mapping techniques with UVs as well as triplanar mapping, blending multiple materials together, and even creating our own master material with exposed parameters that let us customize and create new materials quickly without having to repeat work over and over. This video should be your golden reference for all things materials and will set the foundation for future projects where we create our own shots and scenes from scratch. Now, if you're new to the channel and wondering why you should listen to me or why you should subscribe for future videos, let me introduce myself. I'm an artist who spent the last 6 years working in 3D full-time with Houdini. I've completed dozens of projects using a variety of software, but Houdini has been my favorite software to learn and the most enjoyable software to use. It's also been the most beneficial and high leverage software I have in my toolbox, but it wasn't always like that. My attempts at learning and using Houdini in my day-to-day projects were a scattered mess of years of trial and error and countless mistakes. I wasted hundreds of hours and thousands of dollars with tutorials and courses on Houdini, only to learn that those workflows were either inefficient, outdated, or taught by someone who wasn't able to clearly explain what I wanted to learn. My goal with these videos and with this channel is to save you the headaches I went through and provide you with the applicable information and workflows that I wish I had access to when I started my Houdini journey. These videos are what I would teach my younger self if I had the opportunity to share my current knowledge and what I would reinforce again and again until it became second nature. So, if you're interested in learning how to work and use Houdini in a productive way, or finally get comfortable enough with the software to stop watching those tutorials and start to create what you've been imagining in your head, subscribe, download the project files, and let's get to learning. As we get started today, I greatly encourage you to watch the video through in its entirety at least one time all the way, and then later, if you refer back to this video, use the timestamps below if needed. The information I'm sharing will be important for later projects, and understanding everything I'll be sharing will save you countless hours later when we begin to apply these principles to the projects on this channel. Or more importantly, when you use what we learn to create your own shots and projects without following along here. Everything I'll show you today has been incredibly useful for me, and I hope you get the same value from it. Now, if you're brand new to 3D or brand new to Houdini, then don't worry. You're in the right spot, and starting your journey today is the best decision you can make. I'll explain everything as we go, and we'll pick up from where we left off in Lesson 1. If you haven't seen that video yet, I recommend you review that before continuing here, as everything we learned in that video will be relevant for today. For this video today, you can follow along as needed and rewatch this video a few times to fully get a grasp on what we'll be covering. I also encourage you to download the project files and explore the setups included as you follow along with these videos. Those files are free and linked below in the description. You're also welcome to use these files in your own projects, whether they are personal projects or paid client projects. Now, let's open up Houdini and get started. Welcome back and welcome to Houdini. Today we are going to start with the materials, but before we do, I'm actually going to reset the workspace to what we had in the last lesson and then explain a little bit about our file and where we're going to be working today. Also, as I continue to walk through these videos and explain, please do remember that I am getting used to thinking out loud, so I might misspeak or have to accidentally call a node by the wrong name. So please excuse that, and we will learn together and hopefully get some cool materials done. So actually, first thing, let me show you where we are. So if you remember from the last lesson, lesson 1, which if you haven't seen, I encourage you to check that out. We learned a lot about what Houdini is. We introduced it from scratch. We learned about workflows, destructive and procedural workflows. Let me zoom in to make this a little bit bigger. We learned about Houdini and how that is a procedural or can be procedural way of working if it's set up the correct way. We learned about our framework of defining a goal, breaking it into tasks, and then implementing that task. We broke down this shot here, this reference, into a whole list of tasks, and then we assigned and organized these tasks to Houdini, and then we created our network, which was the logic of how Houdini works through each task. And then also we learned that the same tasks can be assigned on different networks, but they can achieve the same goal. So that's up to you and how you'd want to work, and that's one of the big bonuses of Houdini, is that it does let you have that flexibility. Next up, we covered Solaris, Stage, and USD, which was the context which we're going to be working for at least today, and then all of the layout, lighting, and materials we'll be doing will be in Stage or in Solaris. We learned that in Solaris and Stage that everything is a primitive, and that our materials, cameras, objects, volumes, if you did watch that fire video, which is a great one, you should check it out. But we learned that volumes are also primitives. And then we also went through 2 examples of setting up an implementation for this reference image here. And now that's pretty much what we covered. Awesome. So now today we're going to extend a little bit actually on our materials here. And we're going to cover a foundation of pretty much everything you'll need for most materials that you would use in Houdini for kind of a general purpose. But this will give us a foundation for creating more complex materials later. And then also as we start to build our scenes and our shots, having these materials is going to be helpful because we'll be able to render those out and make our shots look professional and a lot more interesting than if we just did it without materials. So we'll get into these. These are the material properties that make up a material. There's not everything here, but these are the most common ones you'd use. And then also, yeah, these are our LOP networks, which we did learn about, and then our geometry prep. So before we dive into the LOP networks, one more thing to note is all the textures included in this file were from polyhaven.com, which is, it used to be Texture Haven, but now they have HDRIs and they have assets and a bunch of textures which are free to use for any purpose. And I'd recommend getting textures from there, or Quixel Bridge from Unreal Engine is also really good, but we're not going to be using those yet. We might cover some of those later. But the workflows are applicable to Quixel or these materials or any ones you find online or any ones you'd create yourself. So lots of flexibility here. So awesome. I'm going to jump into the network actually and then reset quickly to get our chapter marks nice and organized. So we'll be right back, and then I'll explain our LOP networks and then our geometry containers. So see you in 1 second. Welcome back. If you've downloaded these files, you'll see all these LOP networks here and these geometry containers. I'm going to jump inside 01 example material properties. And now also, if you do remember, we're in the object context, and this is our home base for everything. The LOP network inside here takes us into the Solaris stage context, and another way of accessing the stage context is going up here to stage, and we could do everything in this context here, this organization location, but we're actually going to be working in LOP networks, which allows us to have multiple essentially stage contexts, and then you can organize. And you'll see here I have one set up. We'll walk through all these, so don't worry about that. Also, you hit U to go up, remember, and then double click to go inside, or hit I. But I've arranged a lot of these setups building off the same structure as lesson 1, and then we'll be walking through also what I just did there. Let me jump back inside that. There's some geometry attributes that I prepared for us to learn about. So let me show, and then we'll let those cook, because that might have just happened. You can also hit escape to cancel a cook. But I'm going to go, again, what I just did. Back to go up. I jumped inside the LOP network, example 02. Right here on shaderball, which was a shaderball I actually modeled in Blender and have included for us to practice with, is this file up here. Also, I'm going to rearrange this workspace by just resetting it to what it was. So up here, reload current desktop. And that'll give us a little more space. So give it a second. And then it was inside here, 02. And then this node here, remember our SOP imports, we let us fetch geometry from SOPs and where in SOPs. If we click this arrow, it will jump us to where we're going. And then that took us right here. In this location, shader ball prep geometry attributes. We'll also remember, if I hit object again to go up, is this one right here. And then one more thing to note, I'm going to jump back into the LOP network 02, is these paths here. This is a relative path right now. So if I did a SOP import, give it a second to think. And then these are the shader balls and materials we'll see in just a minute. So I'm going to select this SOP import here, copy this path, select this new one I just created, Control V or Command V if you're on a Mac, paste that path, and now we'll see this is the shader ball that came in, and this dot dot slash dot dot says from this location go up. So go up a level, go up another level, and then find that other shader ball geometry attributes container. But this is a relative path, and if you typed it in how we used to do it from the last lesson, you would go to this network, select your geometry container, which I believe was geometry attributes, and then our shader ball. Yep, geometry attributes on shader ball, and then the relative path. Again, I clicked this button up here at the top right, and then export relative path, and hit accept, excuse me. And that saves this as a location relative, or a file, excuse me, not a file path, but similar to a file path, relative to this node. So then if this whole network was copied and pasted into a different Houdini file or moved, then it will remember based off this location rather than, again, I hit this button to go up, rather than its relative location to the object context. And that's important because, I'll show you again real quickly, we can place LOP networks, not a LOP import, we can place LOP networks inside of geometry containers. So those can be helpful to organize, but because we want them to remember where they are relative to each other, relative paths can be a great way to do that. So I'm going to delete this. You'll see this shader ball was the same one. We'll jump to where that one came from, and then I'll show you quickly what this is, and then we're going to get moving to explaining some of the material properties and then kind of get moving on the lesson. So it's going to be a fun one today. So this ball, I just selected it, and the reason it's so large is actually Blender units are different. So I just hit space G to frame the selected, space G. The reason it's so big is Blender units are different scale. So I transform it, scale it to 0.01, which will bring it back, and then space G again. And then this down here is the geometry spreadsheet, which we did cover very quickly in the last lesson. So we'll explore that actually a bit more today, because we'll be creating these attributes, which I will do a quick overview now, but then we'll also get into more detail once we actually read these attributes into our shader. So I scale it down a little bit more. The clean removes some attributes, but I keep the name, and we'll also learn about the name attribute later. This was created in Blender by the actual objects of the modeling. So that would be imported here with the FBX, and then the name attribute actually is used in Solaris in stage. So as we import this up to stage, the name attribute will set the scene graph path of our primitives, which I'll show you right when we finish walking through this. So this is a node UV unwrap in Houdini, which lets us quickly unwrap the geometry. If you're new to 3D, you might not know what UVs are. We won't cover them extensively yet in this course. We'll probably get to them a little bit more, but this is a quick node that does a usually pretty quality job of scaling out UVs. And then also what we can do is if we wanted to transform these UVs, we could use a UV transform. I'm going to do the scale right here, and we can make them bigger or smaller. And this would be helpful if you're tiling textures, or if you're actually creating UVs to then texture in a different program such as Substance Painter. The workflow might be a little bit differently than what we're doing right here, but we're just creating UVs to somehow map our textures, which we'll be using later. So I subdivide to give it some more resolution, and we'll learn that the resolution of the object is important because a lot of these attributes are stored on the actual points. So each of these grids, and we'll see W, we can go to wireframe. Each of these lines is a single point. Each of these dots is a point, and they make up segments and primitives, and then also they make up the actual shape of the geometry. So in Blender, they'd be called faces, and Houdini, they're sort of called primitives, but they're the geometric representation of the object. So the more resolution we have there, then the more resolution we're able to get when we add attributes to that geometry. So this one next here is a node that measures the curvature. And to visualize that, I can either actually go in our points. So down here, we'll see curvature. So if I bypass this node, remember, the yellow flag bypasses it. That'll show and hide, because essentially this node is creating that curvature attribute. And then if we want to visualize that, what we can do is with a color node, we can create a color node, color type. We want to ramp from an attribute, which lets us take in a float attribute. In this case, we want to take in this curvature value, this number, and we want to take its position and then output a color based on that position. So there we go. Now this one takes 0, which is the left side here, black, and 1, this range, which is white, and then it remaps that to this color here. So if we slid this and moved this along, we can see the values here incoming are being remapped to different colors. And again, the black can be slid, and you can change any of these colors. So this is just a way to visualize it, but you could also export this up to the geometry level, or excuse me, the stage level, which we will actually do later, and we did cover in the Fire tutorial, but we'll cover this in a little bit once we actually start reading these into shaders. So here I just adjusted it a little bit. We'll also cover this more once we get back into it. And then this scales the curvature, so increases it. And then I did a power function to give some more contrast to it. And then I also clamped it. So when we multiplied it, it would increase the maximum numbers, and we can see this right here. So if I select curvature down here, 0 is the minimum, 1 is the maximum. And if I remove this bottom line, which is this clamp, you'll see right here. This makes it a very, very, very big number, which was that power function there. I'm going to delete this. This is also a wrangle, which we will get into later, but for the purpose of this material shading lesson, we just have some quick attributes, but wrangles let us use Vex to modify the attributes here, and we can do lots of cool things with those. So we're definitely going to be learning a lot more about those later. This one just blurs the curvature attribute. And then this again is a color node. Oops, not that one. COLOR. And I used the C again, the hotkey, to actually color this node. So I'm going to delete that. And there we go. So another one is in Houdini ambient occlusion, which is a measurement really essentially of these closed, tight internal faces, which we see right now. We took the ambient occlusion, we measured that using the mask by ambient occlusion node, and we're not using this one here because this is Side Effects Labs. which if you don't have, I'd recommend looking into. They have lots of super helpful nodes and HDAs that save lots of time. So we might be using some of those later, but for now, we're going to stick with the default Houdini nodes. So this is the ambient occlusion we added. Thickness also measures the thickness of the geometry. So if I give it a second to let it think, or let it cook, is what it's called in Houdini. These were essentially the default settings. So thickness, and then connect it here. Give it a second again, and then we'll review what the actual values here are coming from. So right now it looks like the max thickness it will measure is set to 2, and then that will output the value of the different points and the thickness of those points, which is actually the geometry shading, not necessarily the points, because they don't really have a thickness. And then we can preview again with a color node. So we write this thickness attribute and we can name it to whatever we'd like. So it's thickness underscore underscore. Here in our color, in this node right here, we're saying, okay, read this attribute, this thickness underscore underscore. And if I did that, it'll say, okay, correctly read this attribute, which was down here, and then remap the float values here to, from this range actually, onto this color map. So that's a quick tip, excuse me. And now I'm going to put this back because our shader actually reads it as the thickness value. And we'll get to that. And then this one here is a VOP, which I'll show you really quick. This is an attribute VOP, which is another way we can manage and manipulate data inside Houdini, similar to Vex. So inside this VOP network, oh, it's not a VOP network. It's a point VOP or attribute VOP. But it's an attribute VOP that is now set to run over points. So in a similar way where if we put down a wrangle, which we'll cover more of these in later lessons once we get into some of the procedural sides of Houdini for geometry. But this wrangle lets us choose what part of our geometry stream, or this incoming geometry, we'd want to operate on. And these detail, primitive points, and vertices are the same as these down in our geometry spreadsheet. So an attribute VOP and a attribute wrangle are two similar ways to implement usually the same ideas, and artists typically have a preferred way of working. So you can do most things in VOPs that you can do in Vex, and same as the other way around. I'm going to delete this again, but it's just up to you whether you want to be working with nodes or writing code for the actual Vex. So what happens in here, again, you go up, a geometry stream from this node right here is coming into this first stream. Inside there, this is reading that stream inside. It's getting the P, the position of every point. So it's reading in its position. And then this one, which is relative bounding box, this node is reading in the position and then also input 1, which is by default this input here. So it's saying for every point in this object, get the bounding box of the entire object and then find its relative location on the X, Y, and Z axis. And then what we do is we export that. First we take that vector, which is the 3 float, X, Y, and Z. We split that up into 3 individual floats. So instead of a single vector, there's one X component, one Y component, and YZ component. And then we use a bind to not bring it. This bind actually would bring values in. A bind export is what's used to write values to the actual geometry. So for example, I did a constant and I set this to 125, and then I'm going to delete these so you can see me add it again, a bind export. This will add, currently it's named parm. This will add a value of 125 to every point. So if I said 126, that'll add 126 here as the float value. And the other thing you can do is when you create a attribute VOP, this output here will include lots of common ones you'd output to. What we could do is we could do a color. I guess in VOPs we'll actually use a constant, and then we'll change the float, the constant type signature to color. So here we're saying we want a 3 vector, or an XYZ component for color, and we want Houdini to recognize it as color and give us this little helpful color picker. So right now, if I connect this to CD, this will save out this value to the color attribute, the CD attribute, which we learned is internally recognized by Houdini as color. So another way we can do this is with bind export. Let's say our color which is currently type float but type vector. If I wrote this out, that'll give us this value right here on our actual geometry. But now if I disconnect this, and if I wanted Houdini to read that as an actual color, instead what I could do is a bind export, and then I could change this to CD, and there you go. Now it recognizes that, and the reason it's still a type float is because Houdini does recognize it, but you should change it to the actual type. It looks like it does correct that, but we want it as a color. So you should set your bind export values to correctly what they would be. So that's a quick intro to how that's working here. Again, we're reading in a position value using this node to compute the relative position and then exporting that. And I can also actually do, since this does a 0 to 1 value, if I just connect that to color, we can see the relative position left is full black. So you see 0, 0, 0 is our full black, and 1, 1, 1 is our full white. So that's the farthest on the left along the x-axis, which we see down here. And then if I want the farthest on the y-axis, that'd be this component of our vector. Y and Z would be this component here. If I hit W for wireframe, you can see a little bit better. And then also to hide these UVs, if we didn't want to see those, we can click this icon right here. I'll leave them on for now, but again, click to turn them on and off. Awesome. All right, so I'm going to disconnect this, and these bind exports save our attributes to where we need them. So U to go up. And now this again is just what I showed you. Just inside, we learned that this X position is what case I actually bound it to this X position, Y position, and Z position. U to go up. And this color node is reading in that X position and remapping it to the black and white. And then I just colored our node, again with the C key, to the red. And this is the same thing here with the Y-axis and the Z-axis. And this is helpful later when we'll be shading it. And then right here, just did an out null, which would let us easily find this null's location when we're referencing it from our stage context. So I'm going to go U to go up. And we're back to where we were. That's the shader ball. And then I'll show you the other geometries, and then we'll get started into the actual shader information. So getting those materials started. So this again is just a grid transformed. We have a null. This is very similar to lesson 1, so I'll go through it pretty quickly. Grid, transform, also a null for out wall. This null we learned as output was what we set. So when we go U to go up, again, give it a second. If this display flag was on, then nothing would be exported from this node because it's always saying, hey, export the output, which is in this case an empty null. U to go up. This scene geometry is referenced up here in our setup when we create our environment. And again, very, very similar to lesson 1. I think it's copied and pasted from lesson 1 in specific, but we create primitives, we add in our geometry, and then we are assigning and storing that object and that data on these primitives. So if this is new to you, definitely go back to lesson 1 because we cover this all and we walk through it all. But you to go up, and we'll see every LOP network has the same base setup. I won't jump inside them all now just to save some time. But again, this is our setup for the scene. You to go up. This one's one version of the shader ball without any geometry attributes applied. So we just read in our shader ball or FBX, transform it down so it's big, make it smaller, clean it to remove all the attributes except our name. And the name attribute, actually, it's default on a primitive. So this is the points. It is a type primitive, and this came in as a default from Blender when I exported the FBX file. But this will be important because then when we load it into our Solaris stage context, the name will actually be respected. Name and path attributes are two ones in Houdini that are respected by Solaris. So that's a good thing to know. So you to go up, and I'll show you how that represents to the actual scene graph path once we actually open up that file. So that was the one we're just inside. This geometry attributes is the one we just covered earlier. You to go up. And then this displacement here, jump inside here. This side used a sphere, and to create the sphere, this is actually a few different resolutions of the object, and we'll get to this later when we talk about our tessellation, which is the render time, subdivision, and prep for our geometry. So here we have a box, which again is just a box. We subdivide it to add some more resolution, UV unwrap it, and then the UVs are here, and we can see them on our vertex data right here, vertices, which is a UV, and in this case, a third vector, which is not being used, but it is the 2D representation. In our case, right now it's 3 vectors, but we're only using the X and the Y to map our texture onto our object. And if you're new to 3D, I'd recommend looking up UVs. We won't go into depth yet, but in future videos, we will probably be covering and using UVs a lot because they are very helpful. This match size, just in this case, scales our object up in its position to the same, which is right now the minimum, and then I've offset to make it a little bit off the ground. And match size is really helpful for placing objects. We subdivide it again. W again, I'm hitting go wireframe and not, and then our sphere. In this case here, we're actually going to be using this later for triplanar mapping, but the reason I've deleted this UV attribute, which you can see if I bypass this, is I want to map the textures later based off the position. So I want to get the object's position in space, which I'll store using a rest. And I'll show you again real quickly here. This position. So I'm going to do this right now. If I drop down a null, it's a helpful way to split out geometry and quickly preview what's going on in your network. So right now we have the box coming in. We're subdividing the box. We UV unwrap it. We move the box. And then in this case right now, we delete the UV attribute. So if you see on the vertex data, on the vertices, I have a UV here. If I unbypass this flag, it disappears. So this deletes this attribute. And then what I want to be able to do is I want to store the object's position as a rest position so I can read that into the shader later. And the way I do that is with a rest node, but the way you can also do that is with a wrangle. So this stores the rest and the rest normal, which is the object's normal. And we learned that normals, I don't remember if we've covered those yet, but normals are a representation. If you click this button, you can preview the normals. Right now, this is the vertex normals, but it's a vector that represents where the point or face is facing. So it's direction in 3D space, and you can use normals for usually shading, but lots of effects for particles and simulations. Normals are very helpful for controlling directions and vectors. So what I'm going to do with this wrangle, this attribute wrangle right here, and this is set to points, what I want to do is I'm going to recreate this rest position. And the way I can do that, whoops, I'm going to hit Y to disconnect these and just rearrange that. I can do a V at rest equals V at P. And there we go. That just created that rest position. If I wanted to create the rest normal, which is RNML, I could do V at RNML equals V at N. And now it looks like Houdini recognizes that I want to access the normal attribute. And this is another one, P, V at N. CD is also intrinsically represented or recognized by Houdini, but these are attributes that Houdini can work with without necessarily explicitly defining them. If I did have one that wasn't here, it wouldn't just create it. So if I did V at new attribute, new outer equals V at my, okay, it looks like, in that case it does look like it. It does. So if I create a attribute that Houdini doesn't recognize, or I ask it to say, give me the value of my attribute, my outer, it'll set it as default to 0, but it looks like in this case with V at N, it's set it as default to the actual normal. So Houdini recognized that N is a normal, and that's what I wanted, so it did compute this for me. I'm going to delete that. This node just does that exact same thing for us. And then this mask, if I do, this is an attribute paint. So if I put that in and then hit enter, it lets me get a paintbrush where I can paint a mask attribute. You can see it changing on your object. And then hit escape to exit that out. And then if I wanted to preview that mask attribute that I just painted, I can do a color, ramp from attribute, and I can type in mask. Actually, you'll see if I connect this here, I've already prepared some attributes that we will be reading later in our shaders, and these multiple resolutions of spheres are going to be helpful when we see how these attributes mask to our shader, and then how that actually is done with tessellation and then displacement. So I'm going to delete this, make sure this is the same as when I left it, U to go up, and there we go. So that's our geometry. That's where we're going to be working here. And then I'm going to cut, and we'll be right back again to jump into the actual materials, and then we'll start with the material properties. So going to be learning a lot, and we'll keep going. All right, welcome back. We're going to jump into our first LopNet and explore the setup really quickly, and then some basic material properties. So double click to open up this. And what we have inside here is, again, very similar to what we had in lesson 1. We have our primitive paths defining our base primitives here in our scene graph path. We have a SOP import for our wall and a SOP import for our floor. We merge those together with our graph branches node. We scale it a little bit up. Again, W to hit wireframe. We add a material library, and we'll cover these in a little bit, with two variations of our background. We merge that in, but this time at our background primitive. And then we assign materials to our background primitives. We've assigned it type boundable, which, if I delete this real quickly, this is inside the background primitive. We want to go here and we want to select all geometry primitives, which will add this expression that evaluates to our geometry primitives. So when we click render, after, you see our display flag is on the graph branches. After we select the assigned material, we'll see our material be assigned. So I'm going to turn off our render view, and then we'll explore that in a little bit actually as our first material. Next up, we've got our shader balls, which is just the same shader ball, which I'll quickly show you here. The shader ball without the actual attributes for our curvature and other information such as that. One thing to note, and I just hit space G again, is the attribute, the name attribute comes in by default from our FBX. So if we go down in here to our geometry spreadsheet, inside this is two actual attributes that are default with FBX files, which is the name, which was in Blender when I modeled this, it was the name of the object. So shaderball main, and there's a few parts actually, and then a material path, which was the material that was currently applied in Blender. And you can actually use these in certain ways to do helpful things, but for now, when we have our out shaderball selected, we'll notice the name. So shaderball rings, shaderball base, looks like front is also one of them, and main is also one of them. So remember those four different names here. If I go back to where I came from and select this, you'll see our shader ball is being brought in again with this relative path. We're assigning it $OS, dollar operator string, which is shader ball name here. But then underneath it, we can see our mesh components are now named based off of the name attribute. So that's important now. And the cool thing about that is if we did want to, we can now assign, and we'll do it later actually, but we can now assign just materials to specific parts of this object. So if we wanted to have, I'm gonna hit space G to reframe back in here. We wanted to have one area of this object. And another thing actually you can do is this little eye lets you hide, and this star lets you solo. So right here, shader ball base, we can click the star, which is this drop down right here. We can see this object and this object only. We can assign materials to this individually, this cover individually, the main, or the rings individually. And I'm clicking the star again to unselect it and show everything again. Next up here, we have a few lighting setups, which we've wired into a switch node. And we learned that a switch node lets us select between multiple inputs. I'm going to click this again to turn that off. One thing I did actually set up here is in the switch node, I added this expression $F-1, which if I select this merge lighting here and turn our render on, I also have aces set up. So if you click color correction down here, you can select from untone mapped to aces, which I'll have on the entire lesson. But you'll see here, right now we're on frame 1. This is $F, so frame -1 would evaluate to 0, which is the 0th input in our switch node. And we learned that switch nodes and everything in Houdini, the first index is 0. So if I go to the next frame, frame 2, which now would evaluate to 2 minus 1 is 1, would go to the second input in the switch node. And then 3, which is the third, which is a Karma Physical Sky. We won't set this one up because we're focusing on materials today, but this is a very helpful physical sky that gives us accurate overcast and sunlights and a few other settings that are helpful. And then if I click the next arrow here, that is 4 minus 1 is 3, in which case I've set up these 3 lights, which I set light here from type point to rectangle. And that was this light right here. So I'm going to delete that, turn off our render. Now this is one of the materials we'll actually get into later, but that is the sheen, which is a helpful thing for fabric. All right, next up, a few of these, which we'll jump into in a second. And these I set up as individual materials to help showcase these different parameters. And then a few cameras. So if I go down here, the left ones are actually, if I select this one here, remember up in this section here, no cam, I can select the camera we have here. And I'll render this just for looks. And now remember we're in frame 4, which is the lighting setup coming in from here. But if we want to go to our bright HDRI, which also were included in the files, and we did cover these last time, so I'm not going to review too much. Whoops. dome light is what we had right here. But if I go back to frame 1 and we give it a second, we'll see our dome light. And again, to move the actual camera, we'll click this lock icon, which turns the sidebars red. And if it is not red and we move, it will exit the camera view and leave the camera where it is, which again, we can show and hide. There we go. Next up, a few other things. A render setting I turned on to set the samples, and then a denoiser. When we get to our transmission materials, there's some settings here for the refraction limit. We can set that either on the objects themselves or on the render settings in rendering limits and refraction limit. So we'll get into those and learn about why you would need those. On displacement also, we'll cover about tessellation, which is another thing in render geometry settings that we'll have to do. So let's get started. I'm going to go to switch, make sure input 0 is selected, which will have these materials. I'm going to render. I'm going to give it a second actually. And then I'm going to take a snapshot, which was just this icon here, and take a snapshot. And actually, let's do quickly a snapshot of all of these. So what I just did, I selected our switch to move it to the next input, and you can see the input that is active has this solid line, so you can see it move. I want input 1, which is a collection of transmission materials, which we'll jump into. And these are super simple, actually. This is MTX builder. Same thing we did in the last lesson. And all of these base ones were just set with constant values. So I'm going to delete this. We'll jump into these settings as we actually explore, but they're very simple and we're not using any complicated node setups yet. So switch, input 2. I'm going to render. All right, it looks like there's some kind of error with Karma XPU. So we are going to see if we can fix that because it should be having our transmission materials coming in. You see if I select that, transmission materials are there. Okay, that's one other thing. Karma XPU, you might need to refresh if you're not getting what you expected. And there we go. All right, I'm actually going to go back to our render settings and give it a few more samples. And because I have my node selected after our render settings, remember Houdini knows information about what's above it. So this node will know what has been set here in our render settings. So I'll take that snapshot, go to the next one, and there we go. Looks like it worked this time. This is subsurface, which will be the next property. And I'm going to take screenshots really quickly so we can walk through and I can point out the properties as we go through, and then we'll dive in and actually read the setups for how these were set up. 3, emissive. And one more thing while we're waiting. Emissive does have a setting which we'll set with render geometry settings that allows it to be used as a geometry light, which lets Houdini and Karma render a little more effectively the emissive to clean up the noise a little bit better. So that's a setting you should turn on if they're contributing significant light to the scene. And we'll cover how that is done in a little bit. All right, sheen. There we go. I'm going to stop it. And also you can hear the fans I've got going on with my GPUs. So those might kick in if we render too much. I'm going to go to aces, and that was right click, display correction. And it looks like, again, sometimes it gets messed up with the snapshot. So I'm just going to redo this first one here. The aspect ratio was just a Karma XPU quick hiccup. All right. So let's jump into, I'll explain a little bit about these and then we'll see how they're actually set up. So the 4, 5, looks like 9 properties we're going to cover today are diffuse, roughness, normal, transmission, metalness, subsurface scattering, sheen, emissive, and displacement. Diffuse is the base color of the material, which is generally used for, it's generally a solid color, a texture, or a procedural noise. Right, in this case, it's set to red, 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 and then this technically is not, I don't think, the diffuse, but we'll get to this later. Roughness controls the roughness of the reflections, so how crispy or blurry they are. So right now, this has a roughness of 1. This roughness, I believe, is somewhere around 0.3. This one here is a lot lower, actually. Normal maps are used to create the illusion of detail on an object. In this case right now, actually, I have a bump map set on this back grid material, and that is used to give a little more texture detail without having to add resolution to the geometry. Transmission is the glass, which right here, these are all transmissive materials, and they have different settings such as roughness, IOR, which is index of refraction, and then the transmission color. And then this back one, which is a little noisy, has dispersion, which is a scattering of different wavelengths of light, which will give you this little iridescent or rainbow type effect. And a reference for IORs, index of refractions, air is just about 1, water is 1.33, and then diamond is 2.4, but this is the speed of light in a vacuum versus the object. So realistic values would be 1 to 3, but you can also get creative and mess up with values that are not physically possible, but look a little artistic and could be cool for special effects. Metals, which I'll go back to here, it's a float value that defines whether a surface is metallic, which is in this case metallic, or a dielectric, which is a non-metal, which would be wood or plastic or rock. And then typically these values are either 0 or 1. There's some odd cases where they might be in between in the real world, but you can also mess with that as a creative choice. Subsurface scattering, which is this settings here. We'll jump into all of these. This is the simulation of light bouncing underneath the surface, and it's used to do skin, wax, snow, rubber, or getting this kind of soft lighting effect inside the object and adding depth. And then the radius of the subsurface scattering, which in this case defines how far the different colors of light or the wavelengths of light travel will define the look. So this one is a very small radius with red scattering inside. This is actually subsurface with a radius of 0. And we'll explore this when we jump into that. That would have no scattering and essentially would replicate a full diffuse without any scattering. Sheen is this little Fresnel, and Fresnel is a happening in real life where the reflectiveness of an object increases at the angle of incidence. So the more perpendicular you're at an object, so if I'm looking straight on this object, in this case the object is pointing directly at me, there'll be less reflection. But if I'm looking and it's bouncing right near the edge of an object, then the reflection will be more reflective. And in this case, the sheen is being colored and is used to replicate the glancing angles of fabrics. So if it's velvet or felt or any other kind of use for this one, but it's typically done with felt or very, very, very small fibers inside the fabrics. Emissive was this one here. This is a light that is emissive. This one's orange, this one's green. You can actually see with ACEs. You see ACEs does a great job of decreasing the saturation of these lights as they get, as they get very bright. So if I go down to this exposure, I can turn down the exposure and we'll see the color of the light actually does come back. So this happens in the real world where if light gets too bright, its saturation gets blown out, and it's a very important thing if we're trying to create realistic emissive materials or realistic lighting. And this is 0 is no emissive. So these values, all these materials here, I'm going to reset this back to 1. All of these have an emissive value of 0, and this has an emissive value much greater than 0, probably 15 or 20. And then these would be used to replicate LED signs, light bulbs, lava, or lightning, or other effects. And then you can combine these with point lights if you wanted to have these contribute to the scene a significant amount. Displacement actually is not shown in this network. It's in a different network. So I will jump up really quickly. If we go to example displacement, and I will render this and we'll explain displacement, and then I'll jump into the individual settings that were set on these in the other network. I'll give it a second. And displacement is the displacement of object geometry at render time, and it's often combined with tessellation, which is a division of the object's surface at render time, so you can have more geometry to displace without having to have that geometry actually on the object baked in. So I'll show you in just 2 seconds here. I'll let that get to 100. And it can be positive and negative. And then tessellation is that division, or dicing is what it's called in Karma. So you'll see here, these grids here are the actual points on our object. But if we look here, it's dividing this object into much smaller pieces and then displacing those pieces. And that's helpful for rocks. In this case, this is the grid that helped us see it, but we'll explore the tessellation settings as we dive deeper into displacement. So that's these. If you're familiar with 3D, you've probably used a lot of these before and probably have used even a few more, but we're not going to go too crazy into those because this is a basic overview for about 90% of the materials you would be doing. All right, let's get started and back into 0-1 example material properties. We're going to get started and we're just going to jump into the base color, base material. Whoops, not storm. It's another viewport in Houdini. I'm going to give it a second and then go back to Vulkan, and then we'll keep going. So we'll make sure we have our input 0 selected, and we have these material library here and what's happening right now. And again, I'll explain this once and then maybe skip through them so we're not spending too much time. These materials are inside. This node is fetching the materials inside. So all of these ones here are being pulled up from our material network, our material library, into our Solaris stage context, saying, hey, go inside, fetch this VOP named base material, and then bring it up and assign it to our scene graph path with the path base material in the prefix /materials. All right, actually, I'm going to cut and we'll be right back in 1 second. All right, welcome back. We're actually going to do, I just forgot, we're going to cover this background material first, but we will get into these later, and then we'll go kind of node by node. I'll explain these, and if it does take some time, that'll be fine, but I will leave chapter marks for you to skip ahead if you'd like, and then you can skip ahead to, I'm going to go you to go up. You can skip ahead to these if you'd like to go into the more advanced settings. But to be thorough, we're going to go slowly, one by one, and I'm going to try to explain these all. And then if you want to stick with us the whole time, then that would be awesome. But if you do want to skip ahead for actually implementing the materials, that'd be great. But you can follow back here when you want to see how these are done. And then in later lessons, when we come back to create our own materials, this video should be the reference for all the properties you'll need. So let's get started back up here. I'm going to actually go to the lighting before we've added the materials here. Going to render, and then we're going to jump inside and see our background materials. So in here we have our materials brought up again, same exact way, and I won't explain every time just because I want to make sure we're not being too repetitive. We merge those inside on our background primitive with our, remember, our all geometry primitives. This actually can delete. Well, actually, I'm going to hit Control Z to undo that. This is the light background and dark background. And then I assign that, and then inside this material library, we'll see these. And I'll actually show you how to recreate this now. This is a Material X builder. Give it a second. Let's say this our new material. Inside these materials, and right now we have the dark one, I believe it is. If I want to see the light, what I can do is go back to this assign material, check that, and there's the light variation. You're welcome to stick with either one. This was just for different looks and different bounce lighting across the shader balls, but whatever you'd like to keep working with, you can toggle that on and leave that. So dark is the one we're going to stick with. Light we won't be using yet, but it's the exact same, except for these parameters, which I'll show you how to set up. Inside here, what we have is we have an image scale. And actually, one thing to note is I believe these grids should be UV unwrapped. So I'm going to go up here and I'm actually going to take a look. So in our wall, I'm going to jump to where this is, which is Object Scene GeoPrep Wall. Okay, it looks like they're not, but I guess Houdini does that by default. So to be thorough, I'll actually do this. Oops. UV unwrap, and there we go. And this will allow us to map our textures onto the grid with a controllable and an expected representation. In this grid right here, this is a UV preview grid, which shows the size and the distortion. So if these letters and numbers and grid lines are distorted, we can see that we might have problems with our UVs. So I'm going to go back, jump back inside this material library, back inside this checker background dark, and then we're going to explain these. This is a tiled image, which is Houdini's and Material X's, in which case we're using Material X because we're in USD, remember? USD is implemented in Solaris, so everything we're going to be doing is going to be Material X to stay consistent with USD. So this is a tiled image, and right now in this case, we're reading in our checkered grid. And I'm going to show you what that looks like. If I go to HIP and go to Assets, Textures, Checkered Grid, looks like this one. And the .rat files are Houdini's files that are converted when you render. So you will not have .rat files. Again, tools, edit background images to move. But when you do render, Houdini will generate those. So this is an image that I created in Adobe Illustrator, which is just a black and white with opposite black and whites. This image right here, if I connect this to our base color actually, and render, we'll see, here we go. And the two ways we can actually scale this is we could change this right here, which in this case I promoted the parameter, which we will also cover. Or what we could do is go back, you to go up, you to go up, go back to our scene wall, and we could do a UV transform, and we could scale our UVs down here. Before, I'm going to Alt drag to duplicate that. Before it comes in, you see? Or what we can do is we can keep these UVs the same, and then we can scale that in our material. So if you get lost, space F will still also frame you in a network here. So in this case, I have this scale parameter being referenced down here, which I'll also show you how to set up. And now you see, since we changed the UV tiling with the UV transform, these are now a different size. So let's set these, actually let's leave them for now, and we'll modify these later. So what happens is this image is coming in. Currently, it's just going straight to base color, but I added a color ramp, which let me remap the color values to, in this case, a gray and then a slightly different gray, which we can see here. And this is being controlled if I hit U on this level, which we'll also set up. Same thing is done for roughness, but with a float ramp. So instead of remapping it to a color, I'm remapping it to a single channel. Instead of a RGB, it's just a single float, which is going into our roughness. And then this one is actually the same image. I'm going to load it in, but it is blurred. And the reason I blurred it, tools, edit background images. The reason I blurred it was to get a slightly better rounding on this area here. So it'll look a little more organic because it's not as harsh of a cut on these objects when I use it as a bump map. And the way I use it as a bump map is I import the image and then I remap this channel. And since it's a black and white image, I'm setting its signature to float. I'm remapping that float here, in this case with nothing. So 0 is staying 0 and 1 is staying 1. I plug that into the height of a bump node. I leave normal and tangent as the default since we're not modifying those yet. And then height I set with this value, and then scale is the power or the scale of this effect. And this is being controlled one level up. And displacement was just the default. Nothing's being connected there, so nothing's being done. So U to go up, and now this bump scale, which we'll set up again, if I increase this maybe to 1, you'll see the bump effect get a lot more prominent. You can set this to very absurd amounts, but it won't really make a difference. In this case, I wanted a very, very, very slight rounding to catch a little bit of light and make it more interesting. And then the light background is the same, but just different colors here. So let's set up, I'm going to delete this and redo it. Let's set up our own one from scratch. So we'll do Material X, Builder, say New Background, U to go up. Now first what I'm going to do is I'm going to promote this. So I'm going to bring this new background up and I want to assign it to our objects so we can see what we're doing. And what I just did was I hit Autofill Materials, which now brought in new background and assigned it to Materials / new background. But we don't want that. We just want new background. That'll put it right here with the other materials. We then graph that in. And then here on our assigned materials, what we can do is we can duplicate this by copying and pasting. So Control C, Control V, or we can drag our background primitive, and then go to all geometry primitives. And this slash, we'll actually see if we need it, but we might not. And then I'll type it out. So background, materials, and then our new background, which is the material we just created. And let's see if we didn't need this slash. All right, looks like our scene, our display flag set here. So let's set it below. All right, looks like we didn't need it. We'll put it there to be consistent. But that's another thing. If you're confused about this, just mess with it. You can drag and drop, and you can assign materials as you do need, but you should review and make sure what's happening is what you expect to be happening. So jumping back inside our material library, we will set this to green. There we go. The reason we just set it to green was to confirm that our linking was correct. All right, now what we want to do is we want to get our tiled image, and then we want to load in our float. Actually, we'll leave it as a color, because we're going to use this as the base color. Oops. Just rearranging that. We're going to load in from hip. And we want assets, textures, and we're going to do checkered grid. Now we have that one selected. We're going to do color ramp, which is going to let us input our color in, in which case it's expecting a float, but okay, it looks like actually color ramp does do this. So let's see what we had before. But since we are using a black and white, all right, we have as a float coming in. It'll be fine. But if you were remapping a color to a color, you might want to either take a single channel of that color, maybe the red channel, and then remap with just that channel. So what's happening is more of what you expect to happen. So there we go. And now if we did change this, we could set this to a gray and a gray. And then we'll refresh our view. I'll drag, give it a second because I'm recording while rendering. Let's make sure this is happening. All right, there we go. So that color is correctly being represented there. I'm going to turn this off, and then what we also want to be doing is we want a height map and we want a roughness map. So for those other two ones, I'm actually going to use the blurred image. So I'm going to do checkered grid blur, and I'm going to do a float ramp actually. And then this is going to be plugged into our specular roughness. And this is a 0 to 1 value, which we'll review when we review the shader balls of the roughness of the object. So 1 is full rough and 0 is perfectly glossy. So this is remapping the 0 to 1. In this case, black is 0, so full glossy, and white is 1, so full rough. Then we're going to do another one for bump. We can name these. This is bump. We're going to input height, and then what we're going to do is connect it to geometry, normal. And we'll see. It's a very prominent effect now, but we can decrease this scale. There we go. And now what we'll do actually is I'm going to select down here where we have our lights so we see it a little bit better, and then we're going to promote all these parameters. So I'll render it again. There we go. And what I want to do is I want to promote these parameters so we can make these changes without having to dive inside here. So first I might increase the bottom roughness, which is going to increase that roughness on the black. Maybe our bright color could be a little bit less bright. And then maybe our bump. Let's invert it. So if we click this button, that'll flip our ramp. And now we can see whichever way we'd like to have. But we'll leave it here. Bump looks good. Roughness we can invert and just see what happens. And again, this takes the 0. So right now this is the original black image comes in, and it's remapping that to 1. And this is the original white coming in and being remapped, in this case, to 0.1. I'm going to flip it and leave it back, and then we'll promote these parameters. So U to go up, and to promote these, in the same way we did this, what we're going to do is we're going to go up here to edit parameter interface. And this is now allowing us to edit the parameter interface, which is these. These are the parameters, remember, from our new pane type. On parameters, I'm going to X that out because we want this one selected. We're going to add a new folder, and we're going to name this our settings. All right, now inside here, what we can do, again, this is the edit parameter interface. If we double click in here, we can drag and drop these and we can arrange them and use these folders to set up where we want them. So what I'm going to do is I'm going to add 3 more folders and I'm going to set these to simple. And that's just the structure, and I can show you collapsible also, which is another helpful one. I'm going to do the file, and I'm going to name this to color. Actually, this second one should be roughness, and this third one should be bump. And then it is good practice to also name your folders. So these are the names when you're referencing them that it will be set to, but then the label is what's going to actually show up on our material. And we're going to say this is our checkered image. So if I go up, actually, nothing is here, but if I click apply, there we go. Inside our settings, we see currently only color because that's the only one that has a value inside it. So if you change from collapsible here to simple, this arrow will go away, and then inside color we can select this ramp which we added, drag that and say remap color, and we'll do this ramp color. Roughness, we'll do the same thing, ramp, say remap roughness, and this will say ramp rough. And then bump, we'll do the same thing as well. Remap, bump. And then also for bump, another parameter we'd want to control would be the scale here. So we'll do bump scale. And then also the way I'm doing this is tab takes you to the next box, and then shift tab takes you back one box. So apply, accept, and now here we go. Same setup here. Also looks like actually our scale. So let's add a scale tiling here. So I'm going to go edit parameter interface to bring this up again. Make sure our new background is selected. And the way we would change the scale is on this UV tiling, but instead of selecting this node, changing the tiling and selecting this node and changing the tiling, what we can do is use a material X constant. We're going to set our signature to vector 2, which is right now you see this is a vector 2, so a 2-dimensional vector U and V. And we're going to connect the UV tiling. And now if we set this to 1 and 1, what we could do is we could promote this, so scale. We can drag this parameter up to here, and we can rearrange these by clicking and dragging. We can set this to texture scale. And I'm going to apply and accept to close this window down. U to go up, and now there we go. So Karma XPU, to check if it's working, we're going to set this to green. And let's do a dark green, maybe. Make this a little darker. There we go. And now if we wanted our roughness to be different, we can remap this roughness, maybe full rough, or maybe we want it as a glossy floor. So in that case, we could take our roughness down from these zeros. So this is again the black image coming in and the white side of the image coming in. This will make it a little less rough. And if we wanted 0 roughness, we could take this image or this little knot and set it to 0. And there we go, perfectly glossy. And again, you can click to add the knots. And also click and drag down to remove them. So we're going to leave this here. We'll increase this. And then our bump here also does the same thing. So black coming in and white on the top. The scale here. And I'm going to set this to a darker color. And then that way we'll be able to see the effect of our bump a little bit better. So I could flip this if I wanted to see. And white is going to press them up, and then black is going to press them down. And this is a similar thing to what a normal map would do, but you only need a single channel. And then I can also make this smaller. Or remap this. And this would be more helpful if you're using a more complicated image. But for now, this is our purpose, and this is perfectly fine. So we're going to go U to go up. And there we go. So that was the background we created. We read these in, tiled image, remapped this, and then created these parameters up here for us to quickly change and make adjustments if needed. And I'm actually going to go back and I'm going to disable this because I'm going to stick with the background dark we had earlier. Turn off our render view. And now let's get to these Let's get to these material parameters. All right, so inside here, we've got our scene graph. Graph branch is coming in. This is split, assigning material library, and then assigning these to our objects. And the way I'm doing this right now is base material, metal, all these 5, one of each is just being assigned to one of each of these shader balls. And if I did want to use these other name attributes here, which were imported, what I could do is I could assign individual ones. So maybe on shader ball, on no numbers, so the shader ball is this left one here, I could assign to the rings new primitive, and I just click this plus again. And if I wanted to assign this the purple one, and there we go. So now this part of this primitive with the shader ball rings primitive defined by our name attribute is now getting this material, which I named base metal cart paint. And I actually used a coating, which is another one we haven't covered yet, but I'll show you what that does. All right, well, I'm going to remove that. Another thing you can do is you can use CPU or XPU. XPU is the GPU and CPU combined. CPU might be quicker in some cases or give you different results. So they might render different. Subsurface scattering, for example, might look a little bit different in CPU than it does in XPU. But let's go inside base material. And again, this is just material X builder. So I'm going to delete it, jump inside. All I've changed here is the color and the roughness. So if I change this color to blue, I'm going to switch back to XPU. And the roughness here is defining how reflective our surface is. So 0 is going to be perfectly smooth with clear reflections, and 1 is going to be full smooth. And another thing to note is when you have roughness, the brightness of your reflections are also decreased in general as you get more rough. And this is because of the conservation of energy. So as a light comes in, the more diffuse and spread out its reflection is, then the less bright individual parts will be. So we'll see those bright highlights here. And full roughness will have 1 in a smooth object. And that's all I changed for this one. So we'll get into all these later and then even set up the displacement and stuff once we get into creating our own actual master materials. All right, next one, all I did was I changed the exact same thing, and I colored actually the specular. So that's another thing. With metals, the specular color is by default the color of the metal. So that's how metals work in 3D. But right now for this, if I turn this roughness back to 0, I can see our color is tinted with a white specular, which is how most materials are. I can tint that color, and now in that case, it's slightly tinted green. But I leave it as white for this material. And then metals are a type of material that tints the reflections to the color of the metal. So this is the same right here, and you can see it's not quite as rough. If I set this to 0, again, I'll see a very similar sharp reflections. And I can tint this. Wish I had this color open, it looks like. And that can tint. And that can be used artistically for these materials or for metals. In which case, let's see if this happens. I'll slide up the metallic, the metalness factor here. And there you go. You see it tints to a slight reddish. So if I change this to green, now that's a slight greenish. White, and it will tint it a little bit green. And you can also combine this. Okay, you cannot combine this. So metal does override that. So you can see right now it's tinting it green. But if I go back here, I can even decrease the exposure a little bit. It'll be tinting it that slight orange. And the blue, there we go. Turn that off for 1 second. You to go up, and the next one, which is this metal here, this is the same material with just the metalness factor here. And again, the roughness of the metal is defined here by the specular roughness, and that can go 0 all the way to 1. And then one other thing to note for all these other parameters, some of them are implemented by Karma XPU and some of them are not, because this is a material X. This is a USD material, which implements all the different render shading and settings you can have in USD. So right now, to click this question mark up here on the top right, this takes us to the documentation for this current node, and we'll see quick previews of what these all do, which is also a very helpful thing to review. And also, a few of these are not supported by Karma. So if you're rendering in RenderMan or Arnold or another render engine inside Solaris, which is called a delegate, a Hydra delegate in USD, but those might support these different settings, those might not. So we're going to cover a few of these. But if you want to dive extra into depth, you can review this documentation here and learn about what they do. And then also the best way to do it is just to explore and just look around the scene and see what it looks like when you change things, what happens when you change different things at all. All right, up to the next one. This one, it's a metal that I set here. So a purple metal, specular right now. It's being overridden by our metalness, so this technically has no effect. But if I decrease this back down, our coat actually is still here. So if I turn off our coat temporarily, the specular roughness is now being controlled. If I turn our metalness up, that'll create a metal look on our material. And then what I did with the coat, which is another layer, and if we looked into our documentation here, we can read about what it says, but I used this to add another layer of reflections right on top of this to replicate a car paint. So I'm going to go down really quickly to coat. A clear coat layer on top of the material, such as car paint or an oily layer. So if you're doing gasoline on a puddle or other effects like that. So I'm going to X that out. And then this coat, you can see it does have the same rough specular reflections underneath. And then I added the coat layer on top to give it that additional reflection around. In which case we can have 2 layers of these reflections. So the rough one underneath and then the smooth coat. Or we can make it a perfectly smooth coat or a more rough coat. So that's up to you to decide. You to go up, and we'll look at the next one here. This next one here was a quick note actually, and I will pause and be right back, but this is an important thing with the transmission. All right, welcome back. What I did want to actually show you here on this one. So again, base specular IOR example. And if we look, sometimes it doesn't show the material because it's set to transmission. So if it's not showing up in your viewport or your scene view, it might be needing to go into wireframe to see that actual material or the geometry. So if I go to Karma XPU and inside here, what I did want to note is that technically this looks like a metallic material, but it's not metallic. It is transmissive with a transmission. So what I'm going to do is I'm going to create another standard surface and I'm going to connect it out to our output, which is going to assign this material now to our object. I'm going to copy this color with a right click copy parameter, and I'm going to do a right click paste values to paste the actual color, and I'm going to turn metalness to 1. And now what we can see is if I switch between these two, they look very similar, but the difference is this bottom one here is a metallic, and this top one here is a transmission with an IOR of 0. So in the real world, in the physical world, IOR values below 1 would not be possible, but IOR values above 1 would be possible, and even higher would be unrealistic, but still potentially possible. But in 3D, we can change that IOR to any number we'd like, and it would have an effect on this. But the reason I wanted to show you is if I was changing this to a metal and it was looking like a metal, but if I wanted to have a transmission and it does end up looking close to a metal, the reason is this IOR here is set to 0, which for some reason in Karma XPU or in Karma here, in different render engines it might work differently, but this replicates a look of a metal. So if I set this IOR index of refraction to 1, and the specular IOR controls both the specular and the transmission. This means the light coming in is not reflected or not refracted at all with any angles, because the IOR, which is the ratio of the speed of light in a vacuum to the speed of light in this medium, which in this case would be a shader ball. But if I increase it to 1.4, it'll look closer to what water would look like, which I think we remembered water was 1.3. And then the roughness also here is what is changing the shading specifically we see on the outside. And then this dark area is because our refraction limit is not set high enough. We will cover that later, but you'll need to increase the refraction limit amount to a value high enough to allow all the rays to bounce through these different layers of geometry. So again, the reason this was looking like a metal was because it was a transmission material with an index of refraction of 0, which was just an odd thing I wanted to point out, because as you're shading objects, you will be doing lots of changes here, and you might want to maybe artistically select a value, maybe an IOR of 0.1, or different ones that are more unrealistic but could be useful for artistic purposes. So I'm going to continue. We're going to move on to the next one. And back up here, we're going to set our switch to 2. And one thing as we continue going on through these materials, whoops, our cameras were down here, but I'm going to go back to Karma XPU. And here on transmission, I'll actually show you that refraction limit. That's actually the subsurface, and I did set a subsurface limit. So here, if we do want to change this lighting, we can just go, again, the different frames, and you're welcome to stick to whichever lighting setup you'd like, or you can even create your own, maybe wire it in, and if you wanted to, you could extend your timeline at the bottom to include extra frames. So back to 1. Inside here, and I'll actually show you really quickly, this refraction limit is set on a render geometry settings. Whoops. That's not what I want. I accidentally typed a value there with characters. So render geometry settings. And I set that on the certain primitives, which in this case is our props primitive. And I want to increase our refraction limit. So if I set this down to 1, you'll see there's only going to be 1 refraction through our objects, which will not give it the look that we're actually going for. If I set this to 0, this will have 0 refractions through our object. So what, 2? I'll get 2, and you'll see these situations here where it's bouncing in and out. And if we did want to see our front cover only, this is just able to preview that one object, and it's showing the HDRI map behind. So if we wanted to see that map behind this, we can go D, display environment lights as backgrounds, and then we have to be outside of wireframe. So W, we'll go to wireframe and we'll also hide this background, but D allows us to check the setting here that shows our HDRIs in our preview render in our scene view. So W will hide that. And again, we can solo individual parts of the object. And the reason why we had a few dark areas there was because our transmission was bouncing in between and we didn't have enough refraction limits to allow it to be seen. And now you can see the dark edges are only here where there's many, many bounces. If we increase that, those will go away. So that's one thing to note as you do your shading. Another setting which you might need, which we won't get into today, if you are looking for nested dielectrics, which I believe is a shading of refraction materials inside a refractive material. So water inside a glass of wine, or wine inside a physical glass, you might need, caustics we'll get into later, internal reflection, which might be a setting you need to turn on if you want to have ice cubes in water or a glass of water with glass inside it. So different use cases might need different settings. So we'll get into these later when we're actually doing shading on projects and maybe setting up some more of those complicated objects such as glass underwater, but that might be a setting to take a look at if you're looking to do a specific type of shading. So I'm going to now set it to do nothing, which will again leave it as default. And then we'll jump inside the material library. Again, 5 materials here are assigned to the 5 shader balls here. I'll jump inside. I'm going to turn this off to give my computer a second. And you can hear the computer fans are turning on because I have quite a few GPUs working here. All right, so this first one is just a base example of transmission. How I set this was I just had our transmission value from our standard surface increased up to 1. The depth also, which I'll show you in a second, allows us to tint a color. So if we tinted it orange, and right now it's saying at 0 units, begin to become this orange color. But if I increase this, it'll take longer for it to travel through the object to become that color. So it'll say, okay, travel 10 times farther, and then after you travel that distance, become the color which I am assigning to you now. So this might be helpful if you have a very thick glass and you want to have different colors at different depths. But we can leave it at 0 for just a base tinted glass and actually put it back to white. The dispersion and I think maybe the scatter are 2 of those parameters we did mention earlier that were not supported by Karma. Transmission scatter and this one as well. Anisotropy. Anisotropy. I think might be how you pronounce it, but we're going to excuse that. These are not covered by Karma, but if you're using a different render engine or in USD it's called a Hydra delegate is the term for it, then you might be able to use these if you're an Arnold or RenderMan. I don't use those, so I don't know if those would support it. All right, So up next to the rough internal one, this is the same material exactly again. All I did was I increased the roughness. So this roughness on the inside is going to be a foggy effect that is applied to the inside scattering of our glass. And you'll notice the outside reflections are still clear and crisp. So if I set this to 0, we'll have clear reflections throughout. And if I set our specular roughness to higher values, we'll have a smooth or a more diffuse, a rougher reflection on the outside of the glass. And this roughness here is on the inside of the glass. So we can still have a crisp reflection on the outside, but a foggy look on the inside, which might be what you're going for. So I wanted to show you that setting as well. I'll put this to 0.2. All right, on to the next material. This is a rough surface, which I actually just showed you, is this roughness on the specular side, and it is combined here with a transmission roughness on the inside. So 0.15 here I had on the roughness for the transmission, and if we set this higher on the outside, we'll see the rough areas of our specular reflection being blurred and diffused a little bit more. And this index of refraction, remember, it controls both the index of refraction of the specular reflection as well as the transmission. So 1 would be no refraction, through the object. So the speed of light would be the same, so there would be no bending of the light as it enters this medium. But if we increase it to 1.4, that'll be more like water. We can increase it as high as we'd like. And this is another thing. If you increase it really high, it does reflect metal. And if you set it to 0, it also does replicate the look of a metallic object. And you can see you can get different results when you set it below 1, but that would not be possible in the real world, in the physical world. So since we're also creating artistic objects and shading, we might be needing to do certain effects that would not be possible in the real world. All right, next up we have transmission color, which we have seen before. That is again just this color right here. You can change that to whatever you'd like, and then the depth is how long it will take that ray to inherit this color here. So you can see right now the thicker areas are slowly tinted a little bit more red, but the thinner areas quite don't have as much red. And another option actually we can do, which we're not going to get into caustics yet, but you can see the red area behind this object. I might even be able to switch our lighting to 2 to see it does tint our shadow area a little bit towards a yellow. But if we go U to go up, and then on our object, if we enable caustics, that will disable this from tinting. So if you do want it to tint or not tint, this is an effect we can do here. And we're not going to get into actually creating caustics yet, but we might get into that later for trying to render some nice caustics from our refractive glass. All right, so that was the transmission color. We can also change the specular color of the reflections. And then the next thing we have is dispersion. Disable that to give it a second to think. Dispersion here is the different, this is the one we want to look at. Different wavelengths of light will be refracted at different angles. And in this case, since we're not necessarily using wavelengths, it's the different colors of the light. So if we set this to 0.01, we can see it has a different effect than if we set this to 0, which will have no dispersion, and higher values will have different values of dispersion. And if we want to see exactly what this value does, we can open up our documentation from this right arrow mark here, and it will show you a quick preview of what the dispersion does. So how much it varies across the different wavelengths of light. In a lot of these settings, the values here might be good suggestion ranges to actually use. And that is another thing about Houdini. Like this right now, you see it goes from 0 to 3, but this goes from 0 to 100. You can set these manually when we actually create our material parameters. We might do that later, but these values are good estimates of what would be recommended by side effects to be tweaking, but that doesn't mean you can't go higher or lower. You see in that case, I typed in a negative number and it blocked me from going negative, but it doesn't stop me from going really high on the index of refraction. So don't be scared to mess around with numbers to see what you can end up with and to see what kind of effects you might be able to put together. All right, I'm going to put this back to an IOR of 1.4, and we're going to put our dispersion to 6. All right, and again, W, when we have the background environment lights displayed as backgrounds, we can show wireframe, and that can be a quick way to hide and see our HDRI backgrounds. All right, U to go up, again, U to go up, and we will look at subsurface. This should be subsurface limit actually, because I set that with the SSS limit in our render geometry settings. And one more thing on these render geometry settings, we can do, I'm going to disable this, which is going to put our refraction limit, down lower to where we had these dark marks inside our glass again. We can also set this refraction limit either per object on render geometry settings on a primitive. So if we wanted just one of these shader balls to have different refraction limits, or what we could do is set those in our render settings. So you see it has a refraction limit under rendering limits. We can set that to one value and then that will change. But if we change the geometry settings also, then that will be different, and that can have, maybe we only want to have certain objects have a refraction depth of 6, or in this case, we set it to 6, and then we want everything else that we didn't manually adjust to have a refraction limit of a different amount. So there's two ways to set those. On the other ones, you can also set them per object, but an easy way to do it is a catch-all kind of in your Karma render settings. Or if you would rather prefer to do it object by object, you can do that, and maybe you can save some time rendering if you optimize each material a little bit more. All right, well, next up we've got subsurface. Let's set this to Karma XPU. And then we will jump inside here. So again, same setup. We've got 5 materials on the inside being brought up with our material library. U to go up. We have an assigned material, which assigns those to our shader balls. I'm going to go back to 1. And we can see the little bit different lighting. Also, I think it might have been 4, frame 4, which again, these frames are changing our lighting setup because I have this expression here. So right now in this case, I have some area lights behind these shader balls, and one of them looks like it's tinted a little bit blue. This can be a helpful way to see what your materials are doing in different lighting setups, and maybe you want them to be consistent throughout different lights. So if you have an outdoor scene, an indoor scene, or a studio lighting setup, you might want them to look a certain way. So as you set up materials, it's helpful to be able to look at them from different angles and then different environments. A correctly made material should look consistent and correct through multiple lighting setups. All right, so now inside our subsurface material properties, we're going to jump inside. Base subsurface is assigned to our shader ball. And again, we could assign these to the individual objects. So I'm going to pause this just to save some rendering. And if I wanted to assign This is what, 0, 1, 2, 3. So if I want to assign this orange material to the rings of this blue one, what I could do is add it. I'll do another assign material actually, why not? And that's another thing you could do. If you want to have multiple assign material nodes, you can do certain assignments in one node and certain ones in another. And instead of this switch, you could just disable or enable assign materials. So let's say make blue rings orange. So I want to assign shader ball, which in this case was our leftmost one, and we can see just because that's what I named it. I want to assign the rings in our shader ball, and I want to assign that base subsurface B. And there we go. We could even assign, why not? Let's make the base, let's make it, I think the pink one is maybe D? I don't remember. Pink looks like it would be assigned to 4, so C looks like it's the pink. I probably could have named these a little bit better. And now you can see this is a little bit more of a thin material, so it might not be as tinted as dark as this one, which again is a thicker material and is because of this subsurface scattering, which is simulating the light scattering inside the objects. All right, I'm going to disable this assign material, jump back inside our material library, inside subsurface, and then we'll look at the actual settings. This is just under subsurface. Right now it's no subsurface and 1. One other thing to note about subsurface is it does override, at least I think it overrides our base color. So you see this is green. We set subsurface to 1. That will make it a blue. And our color here from base will not be used anymore. And then these two colors are blending between the actual color of the subsurface scattering effect and then the radius, which is the distance inside the object that it can travel before being scattered. And the best way to figure this out is just to mess around with it. So if I tinted this radius to a red, it'll have a different effect. Or if I tinted it to a purple. And the other thing about the subsurface is sometimes you have to refresh the viewport, and then sometimes CPU will have different results and different rendering. So you see in this case, it looks one specific way, and then in XPU it did not look a specific way. So subsurface is still one I haven't used actually a ton in XPU. So maybe in more projects later we'll explore it a little bit. But these setups here were a way to quickly review and then show you guys a little bit more about the colors you can do. And also sometimes if you have values of 0, that would look different than if you had values just below or just above 0 or just below 1. So mess around with these a lot and then explore kind of what different effects do to the actual object. All right, well, going on to the next one. Our scale here was done right now. This is our small red radius, which I've set this scattering here. Now just change it actually to the yellow. And this radius here, if I set this to 0, that'll resemble a fully diffuse object, so without any subsurface. But we can see the color of our color here in subsurface is what's controlling the color of this object. So if I turn off subsurface, it's green. If I turn it on, it's black. If I increase our radius, it increases the radius of the subsurface scattering. And this radius is again the distance inside the object that it can travel. And the scale, I believe, is a multiplication of this radius. In redshift, I think it is a multiplication, but I'm not 100% positive for karma. All right, the next one I think is actually just a diffuse object. Yep. And it looks like I actually copied the channel reference from this one here, or from one of the other ones, but we'll cover channel referencing later when we set up our own master material. But here, if we set our scale back to 0, this left one, which is technically a subsurface material, looks very similar to this right one, which technically is a not subsurface with just a base and a roughness. All right, up to the next one. I'm gonna refresh this rendering. And again, I'm recording and rendering, so it might be a little bit slower than it would otherwise be, so please do excuse that. All right, this next one looks like it's orange, and this is just another version I set up with some slightly different coloring. And this, I think, is the forward and backward scattering of the subsurface. It has a slight effect. I don't know if it has a better effect in certain situations, or you can see a little bit, and I can actually take a snapshot in a second, but I'm going to find it here. The direction of scattering, subsurface scattering, 0 scatters evenly, positive values forward and negative values scattered backwards. So if I took a snapshot with our set to 1, anisotropy, I think it is 1, and if I set it again to 0, or actually I'll set it to -1. I'm going to hide our camera icon and then give Karma a second to think, or in this case 17 seconds, or however long it'll take. $18 seconds, and then I'll set it to 0, and then while we're waiting on that, I can open this up. Color correction, untone mapped aces. I'm going to set this to, I think this was -1, and then take a snapshot, and you see it load in our preview window here, render gallery. And now we can see the slight difference. See 0 evenly. This is -1, and this is 1. And the lighting effect also. So if we go to 4, where we have some rim lights, that might have a different effect on this setting here. Do a quick one. I won't wait for this to load all the way. Take one preview, and then I'm going to show you the subsurface scattering limits. So here we go. Different effects, and if we let this clean up a little bit more, it would look a little bit nicer and not quite as noisy. So if I got U to go up, and I'll jump inside this pink one really quick, which is a very similar setup, but just tinted with the purple and with a slight purple as well. Again, turn it off, see what happens. I can set this to 0.3 maybe. And just messing around with these will help you kind of understand how they are controlling the actual material, and then having an idea of what the changes that are made actually do look like will help you later, and will help us later actually, as we recreate specific materials based on the look of them. So we might look at a reference material and break it down in our framework, and then try to recreate it as closely as possible using all the knowledge we'll be putting together. This is the subsurface scattering limit. So again, if you have scattering effects and they're not quite looking the way you'd want them to do, you can increase this limit. 110 might be a little high. And then this is a similar parameter that you could either set on your render geometry settings or on your Karma render settings. So again, a handy way to be working. And then depending on the way you organize your network, you might have a certain way to do it in a certain spot to put it in. All right, U to go up. Whoops. We actually want to go back inside here. We're going to look next at the emissive, and I need to switch this switch to 3. Let's go back to frame 1 and Karma XPU. All right, now in this stream, this geometry stream here, or I guess it's a stage stream because we're not necessarily just working with geometry. I scale down all of our shader balls and I transform them not in world space but in local space, and then I scaled them down by 0.5. Then I removed these 3 middle ones with a prune, which was just that node here. And then I assigned a emissive material, or I created an emissive material. We'll jump inside these in a second. Assigned those, and then I set a render geometry settings for treating as a light source, which again, if I do render geometry settings, I just selected the primitives I'd like to operate on, which in this case were all my shader balls, and I wanted to set those as light sources. And this will help. I'll actually show you really quickly here. We'll say this is on. Actually, this is not on yet because right now we're selecting this display flag. So I'm going to re-render that with this down here selected. And then we'll give it a second. But what this does is it cleans up a little bit better the noise around the object, and then also helps with it emitting light. But you wouldn't in general want to be actually lighting your scenes with emissive materials. You might want to have emissive materials in the scene and then maybe replicate point lights or place them to sort of fake the effect without having to render actually with emissive materials, because that is very expensive. So if I set this to no, and computationally expensive is what I mean by expensive. So as light source on, and you see it cleans up the noise a little bit better with the same number of samples. Also gets a little bit better color there and a more realistic look. And then this emissive material was set underneath the emission. See, in this case, it's very bright. So you can go very bright, but you could also fake this with a point light if you did want to. This one is not quite as bright, but that is not the one assigned. I think it might be E is what we have assigned there. So if we change this to blue, there we go. We increase the brightness. I think it is E is on 4, and 4 is what we have. And if we wanted to see, what we could do is, there we go. All right, it looks like our prune here, we can see, sets some of this visibility. We're not going to touch these. All right, E. And then also the exposure here is going to be blowing out the color in the saturation because it's so bright. So if you're not in ACES, you might have a different reaction for your color and tone mapping to the exposure of the emissive. So up again. And that is good for now. And we're going to go to the next one, which was sheen. And I'm going to set this to 4 to get that stream coming in through our switch. And back down to here. In this one, I actually pruned the first and the last one. So shader ball and shader ball 4, which were the farthest left and farthest right. I can bypass this flag to disable that prune. And then this again, oops, Alt to right click to move in, is a sheen effect, which is this one right here. And this simulates the Fresnel, which is the lighting effect on the outside of objects, where if you're looking at them straight on, they are more diffuse, but at the angle of incidence nearing a fully perpendicular path. Excuse me. So if we're looking straight at it, whoops, not subsurface. I wanted to turn off sheen. So if we're looking straight at it, it is diffuse. At this angle right now, it is the same diffuse, but if we increase our sheen, that will add this fake effect. And we can also adjust the roughness of this, and then also the color of our sheen we can tint. And this is our base color here, which is below it. U to go up. This next one is the same thing. I just changed the roughness. And again, this would be helpful for fabrics or felts or velvet or stylized materials maybe. You could probably find a cool way. I didn't want to do roughness there. Now I'm just messing around a little bit. And this is kind of the fun part, and I'd recommend you download the files because you can go adjusting, see very, very low roughness. We see this nice little edge. I just typed it 2 roughness in it. Said no, 1 is the highest we can go. All right, we'll disable this and keep going. U to go up. All right, there we go. That looks like it's the end of our example material properties. So I'm going to go U to go up. And again, as we need, we can review or recap here what each effect does. And then also I listed out a few kind of common info or tips on these material properties. All right, next we're going to jump into here and explore our geometry attributes, but I am going to pause and be right back so we can get nice and tidy chapters for our video. All right, welcome back. We're going to continue going, and we are going to jump into 02 example material geometry attributes, which is our second lob network of the day. Space F to frame, and I'm going to zoom in a little bit more. All right, very similar setup. We have our primitives created. We have our wall, our background added. Materials for our, again, W for wireframe. Materials for our background, which is the same checkerboard pattern we covered earlier. So if you're skipping ahead to here, in the last section, we reviewed and recreated this material. We have our shader ball coming in. And we have a different shader ball actually this time with geometry attributes. Whoops, I accidentally typed W. I'm going to hit Control Z to undo. And now it looks like it brought it back. So those are merged in here. We've got the same lighting setup, very similar. And now this time we have these materials, which we'll review and select down here so we can get our render settings, which does have a denoiser applied. Give this a second. All right. Then I'm going to take a snapshot, and then we're going to review and recap again our attributes that we created. Color correction. Whoops, not raw. I want aces. And I'm going to jump inside here, and we did cover this at the beginning of the video. Remember how we set up all these attributes. But again, this one right now, we're looking at the X position. We're bringing that in as 0 and then remapping that from blue to white to yellow. This one, we're doing the Y position, and we'll look at the nodes in a second. But from 0 with Y to red, and then we transform a few different colors all the way up to our black, which would be 1. This next one, I think we did use curvature, maybe it was, which would be generated here, actually above here on our measure node. Did a few operations to adjust this a little bit, preview the curvature here. This next one, I actually combined a few. I think ambient occlusion might have been the glow, and then a little metallic on the curvature, and then another metallic on the general area of the object. And then this next glass one was a transmission with a, I think it might have been metallic, but we'll actually look into it next. So U to go up. So those materials and those attributes, again, I'm going to dive back inside really quickly, are created and stored here on our geometry, so AO, curvature, thickness, X underscore position, Y underscore position, and Z underscore position, U to go up, jump inside this lop network, and I'm going to go inside the material section here, inside our material library, and we'll start with this first one. So how this is working, I'm going to close this actually down because we're going to turn it on in our render view right here. So how this works, we use a prim var reader, which is this one, this node here. If I connect this, I'll actually do a new one, prim var reader. This lets us read attributes, whoops, not on diffuse roughness, from our geometry, and it lets us use these in our shader. So if we typed in AO, which was the name of one of the attributes we created in the SOP level, and we let Houdini think for a minute, there we go. We can see the ambient occlusion that we created on this object. If we do curvature, we will get the curvature we created on the object. If we do Y position, we'll get the Y position. Same with X. Same with Z. Let it think. And this one is the Z. So back here is black, front is white, and also the thickness, which I do not think I used on any of these, but I just wanted to show you another one you might commonly use. And this thickness we could control parameters such as the, let's disable this for 1 second, the render, the subsurface scale. Maybe if we want to control the radius, we could multiply it by thickness. So thicker parts have an intentionally different radius, or maybe emissive. So any of these values here, which I show you in this area here, can be connected to different parameters on our materials and allow us to create really whatever we want. So this one, I take the X position. See if I connect the base color, we can see what that looked like again. Going black from left and then white on the right. I remap that. So right now this is 0 coming in, 1, but I want to remap this. So roughly 0.4 is 0, maybe 0.5 something is 1. So this will bring a tighter difference, a tighter gradient across this. And then what I do is I mix with the Material X mix node. And this lets us mix multiple values based on a factor. So I mix a yellow color here, which I created with a constant, a Material X constant, not a regular constant. We want to stay with Material X because we're in USD. This is a color I just set. So I mixed this color with this blue color. I can connect this to the background and we'll get our pink here. And I lerped between them, a linear interpolation or mix, with our remapped X position. And if I connect the Y position, it'll remap our X or Y position, excuse me, from 0 all the way up to 1. We'll remap that value and then use that as a mask for our mix. Going a little slow. And then Z as well. And this, you can see it's the Z, so the back and the front. And one cool thing about this actually, I will do very quickly, is because we stored these as a attribute on our object, we're not actually, I want to rotate. So I want to rotate it along its vertical axis or on the Y. There we go. And I will show you why in a second. So because we store these on the object, you'll see the yellow is on this front area with this extra ridge, and these back areas is the pink. If I go U to go up and U to go up on our transform, if I set this to 60, you see the color does rotate with the object. 10, and it still rotates with the object. If I set this to 180, it'll flip it around. So we are not using any gradients that are calculated currently based on this object. They're created, stored, and remembered inside the actual object. So regardless of how this was rotated, the gradients here, so if I rotated it like this way, our y gradient wouldn't be up and down. Our y gradient would still be in the same direction we'd stored it and we created it. And that's actually important because later when we use our rest attribute, the benefit of using the rest attribute is we can have animated geometry in our stage level, but when we move that geometry, the textures are not projected in world space, they're projected in rest space. So we can have a object with a rock material maybe rotating and spinning, but those textures are not actually sliding around. So if I jump into B, very similar setup, Y position, remapped here through color, and then through the, looks like the color here. But you can also do, any of these can be remapped to any of the values. So if I had our metalness here, maybe I'll flip this and I will put this here. We'll see what happens here. I'm going to zoom in and then turn our render back on. So this will have the bottom area of our material be a metal and the top will not. So if I flip it, the top will be a metal and the bottom will not. And I can do this for transmission. Let it think. All right, really is taking a long time to think. So I'm going to disable this metalness and I will plug our color into our transmission color. So now we're going to take the same colors here, putting it into transmission, and let's make our remap here a little bit more of a direct transfer. So a little bit sharper of a gradient. And we'll let it think. And this will be taking our Y position, remapping that to the transmission values. And if we set our roughness, we can see top half is a glass material and then the bottom half is not. So if I reverse this, bottom again is glass and the top is not. If I wanted a clear glass, I could set our transmission color to white, and then that will keep this as a clear glass, and then the top will be the same base color we had before, and then its color is going to be set by this ramp here. All right, to the next one. U to go up. Oops. Awesome. Let's zoom in here. Load it. This one, I took a gray color, blue color, again, material X constant, and blended between them using our curvature map, which we also created in our geometry context in our SOP level. And then I remapped that to get a little bit different of a transition. You see how a little bit it's blurred out. So I wanted to make that a sharper color. If I connect that, you can see the transition between the two colors is a little more distinct. All right, it really isn't liking me recording and rendering. Well, that was all. It looks like I also did the metalness also into this one. So the edges here, the curved parts, which were created with our curvature attribute, are mapped to a metal, and then the flat parts are not a metal. So I'm gonna do Vulkan, VK. This could be helpful if you wanted to combine it with scratches. We could use UV textures and those UV coordinates on the object, or even the rest position, to map scratches on these edges, and then we could have a rough metal maybe on one edge and then a smooth painted material on the other, and then we can blend between those based on these curvature attributes. And we will actually use attributes blend between two materials a little bit later in the lesson. And then it looks like I also actually put this into a bump map, which we did cover when we set up our grid material. And that bump map added a little bit extra to the edge of our material. Again, I recommend you just play with these values, see what happens, see what works. That is a lot of what look dev is, and which is a lot of fun, just messing around and creating different looks and different styles for materials. So on to the next one. This one, I took our curvature, remapped it, so 0 is all the way up to 1, and it looks like a value of 0.2 I'm remapping to 0. I plug this into the base color and the metalness. If I disable the emission for a second, actually, we can see a little bit better what that results in. And then I took the AO, which was the internal parts of this object, and I remapped those. And then I put that into a multiplication node, a multiply, which I used to scale our emission. So now this value, I could even promote this later if I wanted to. This controls the brightness of our emissive. So maybe if you were animating some kind of robot power up or different effects with screens, you could control and animate your emission. I'll turn this off. And we can also use these values, this AO value, we could animate that value in SOPs with some wrangles or noises. And then we could import that animated value up into here. So we wouldn't be doing anything in the shader. We'd be doing it in the SOP level. All right, and then on to the next one. And a lot of these tips and tricks are just general purpose ones that you can combine and use as needed. So again, this is the AO, the ambient occlusion. Into here, remapped, into transmission. So I only wanted certain parts to be transmissive, and I could flip this and we get the opposite effect. Now you see only the parts with the high ambient occlusion. Or I guess actually in the lower ambient occlusion. And again, these values, the AO values, are set in SOPs. So if we just do these on an object that you brought in and did not prepare this in SOPs, then it wouldn't be possible. You'd have to create those attributes yourself, unless they were on the object you already created. And there we go. And another one, I took this curvature, remapped it, and then I used it as a height map, which gave a little bit extra definition to the ridges. All right, let's get a quick look. All of these together, maybe disable this transform we set up here. So a lot of these techniques we'll be combining later into creating more materials and effects, but using all these together is a very helpful way to create complicated effects, and you can layer the materials and stack them up, which we will get into the next ones. Awesome. So next up, we're on to textures and mapping those into our objects. I'm going to show you a quick preview, and then we're going to cut and be right back for our chapters to make sure we're nice and tidy for that. All right, we'll actually see this when we come back. All right, welcome back. We are continuing from the last chapter. You to go up to show you where we are in case you're skipping here from a later rewatch of the video. 03, example material textures. Inside here, we have all these textures here, and we're going to cover how to map these to our object with the UVs, and then also these settings for setting up these, and we might even set up a quick master material for adjusting these parameters. And again, all these textures are included in the project files. So we've got a little dirt, grass, we've got some wooden planks, we've got some bricks and concrete, rock face, and then it looks like another kind of dirt material. So VK Vulcan, again, very same setup. Background material, our objects for the background, we applied that material to the background. We add our shader balls in. In this case, If I jump to where our shader ball was created, again in SOPs, we're looking at this shader ball here. So space G to frame it. And this one is important. It does have UVs. I'm going to go to smooth shaded. And then this purple template flag is what caused that wireframe. So these do have UVs, and that's going to be important because we're going to be using UVs to map the textures. And then next, we're going to actually be using triplanar mapping with our rest position. So we got our lighting in here. And then same exact setup. We've got 5 materials inside. Bring them up into our stage context. And then assign those materials with an assign material lop, a node. All right, so inside here, this one is a little more, and I actually did create this, so we can follow along from right here. You should have this node as well. This is a little more involved of a master material. And I call them master materials because in Unreal Engine, that's the paradigm they use for materials. You create a master material, and then you create a child of that material, which inherits all the parameters of the material, and you can set up nice little control panels to use. So in Houdini, we can do that similar with HDAs, but for us right now, we're just promoting the parameters to make them a little more accessible. And the benefit of this is if we had our raw wood color, which I think should be this one here, and if we set our saturation to 0 and gamma to like 0.3, we can change these values without having to jump inside the network and adjusting this color correct. And then what you can also do is take this alt drag or copy and paste and then just switch out the textures, which is exactly what I've done here. So I created one, alt dragged it, changed the exact textures, and then that's a quick way to do multiple materials and then set up. So like for this rebar concrete, if I wanted to tint this to a green, I just adjust the hue, and there we go. Now I've got a nice green rebar concrete. Maybe we don't want it as rough. Maybe it's a little wet, so we want it a little bit more reflective. So we'll decrease our max roughness. Houdini lets me click it. And that will make it glossier across the whole object. All right, it needs to think again. There we go, a little more glossy across the outside of the object. And then these grids here, this little cut is the UVs. So when I unwrapped it with the UV unwrap, it gave us a very rough and not very neat UV unwrapping for this object. But for the purpose of this lesson, it is a fine demonstration to use. So we don't really care about these UV seams because we're just learning. But if you did care, you might spend a little more time UV unwrapping, or you might use a triplanar projection, which we'll actually cover next. So to show you, I'll actually create this material here. But first, this is a diffuse, color correct, and then those go into base color, specular roughness, normal, and then displacement. And since we're on displacement here, actually we'll cover that next, but that's where the tessellation comes in. And I have a scale there. All right, so let's start, and we're going to create our own material. But to start, we should do, let's assign this material. Now I'm going to set it pink so we can easily see it, to the white wood right here, which is currently raw wood color. So I'm going to autofill to bring up our follow along create material. And now I'm going to assign follow along create to this one because that's had the raw wood color. So here we go, drag and drop. And now we have our pink material. And I like pinks and greens because they're easy to see and they let you quickly see if your material assignments are correct. All right, so to start, we're going to need an image texture, which is not an image texture, it's actually a tiled image. And we're going to name this diffuse or base color. It's also called albedo, depending on where you're getting your textures from. This will be roughness. Diffuse will be a color, a signature color. Roughness will be a signature float. And then we're going to do a normal map. Will be a signature vector. You could also do a bump map, which would be a float signature if you're using a grayscale image for the bump, similar to how we set up the background grid material, but we're going to stick with normal, but you're welcome to set up bumps. We're going to do a displacement, which will be a float, and we are going to connect everything, then we'll promote all the parameters. So what we want to do is a color correct. We might want to change the color of our diffuse or the saturation. We want a float ramp. So for our roughness, we're going to want to maybe invert it or make certain parts glossy or more rough. So we're going to say remap rough, and we'll say correct color. And then we'll do another. For displacement, and then we're going to do a subtract, because for displacements, sometimes you want negative displacements or you want to offset the height of the displacement. And then here, we're going to call this offset. And then the names of these nodes are helpful for organization, but they technically do not matter. The parameters that we'll set later are what matters. So this I want in the specular roughness, and the geometry I need a normal map. Give it a second. Normal goes in, out goes to normal. We're going to leave these as the default, and then I think that is actually all we need. Actually, we do need one more. So right now, when we map the image, and I'll actually show you. So we'll go hip. I want assets, textures, and let's do, which one to pick? Let's do our concrete again. So diffuse. Now if I render this, give it a second, our concrete will come in. And the tiling of this is going to be defined by our UV scale. But if we wanted to change the scale, we would change the UV tiling here. All right, I'm going to reset it and then we'll continue working while it loads. We would change the UV tiling here, so 6 and 6. Would scale it to a different amount. Or 0.2 and 0.2 would make it bigger. But instead of changing this one, this one, this one, this one, we're going to do our constant again, material X constant. We're going to set it to a vector 2. Set these to 1.5. Let's do, whoops, 1.5. And we're going to set these to the UV tiling on all of our tiled images. And now U to go up. And now if we did change this, it'll change all of them, but those aren't plugged in yet. So let's get those plugged in. And I'm going to copy this first part of the path, and I'm going to paste it in roughness. And then we're going to select our rough. Our normal. And our displacement. And now, displacement is very big, way too big. So we'll set this to 0.002. And actually, while we have the displacement, what I could do is set this to 0.1 and then the offset. Oops, not CPU. So if our offset is 0, it will displace based on the values in our displacement, which will be between 0 and 1. But if we wanted to move faces or geometry inside, what we could do is we could offset by in this case, a positive value since we're subtracting. I'll take a snapshot once it cleans up a little bit. Let's say that's fine. We subtracted 0.2. Let's say 0.5. Now it shrinks in the displacement a little bit. So some faces will be, or some geometry will be displaced up, and some will be displaced down. Color correct faces. There we go. So by offsetting our displacement, we can control where the actual zero of the displacement is. And then this setting later is the tessellation or the dicing quality, which quickly we do, looks like we leave it as default here. So we'll adjust that actually later in the next setting or the next chapter. All right, so we've got all our settings here. I'm gonna put this back, leave that at 0.5, but I'm gonna put this back to 0.02. So make the displacement scale smaller. And now what we want to do is we want to create these parameters here. So edit material interface. And we're going to go a little bit quicker than we did on the first one, but I would recommend you follow along because this is a very helpful part of Houdini in promoting parameters, and using these setups here is helpful for HDAs or just staying more effective in Houdini. Let's say our settings. We're going to do a folder. We're going to do 4 folders actually. We're going to set them to simple. Let's say diffuse. We'll say rough, normal, and we'll do displace or displacement. Apply, and then we'll do, that'll be fine. You to go up, and now you'll see nothing is here. We drag our settings here. We can say this is texture scale. Apply, and this setting here, if we wanted to lock it to say you can't do negative values, we can do that. But in our case, we actually might want negative values, because if we wanted to invert one of the coordinates of our textures, then we could do a negative value and that would invert it. So we want the roughness image. So we'll say rough. And then I'm not going to rename all of these just to save a little bit of time, but I would recommend you name the names and the labels to something that is consistent. We'll do diffuse. So diffuse image. Diffuse image. Then we want the normal. Oops. Normal image and displacement image. And then we need to do a few settings for our color correct. So this is also you just promoting the parameters that you think you would use. So you can promote as many or as few as you would like. I'm going to say the scale. We want to be able to remap our roughness. So let's say remap roughness, displacement. We might want to do that actually. That might be helpful. Offset and scale. And this will keep the names the same here, but for input 2, that quite doesn't make sense. So let's rename this to offset or displacement offset. So you to go up, and there we go. Now we've got lots of textures here. I'm going to hit apply and accept to hide this, and we'll see if we have all the ones we need. So actually, to show you how helpful this is, That just took us a few minutes to set up. But say we wanted to do a blue rock, or we'll keep the same textures. We'll just copy this here. I'm going to say follow along, create, modify. And now I'm going to take this subnetwork here and I'm going to apply that to this leftmost shader ball. So you to go up, autofill materials, bring it from inside our material library into our stage context, assign materials. I'm going to add a new one. We could add a new one, or what we could do actually is go to here and just override this with modify, jump inside. And then this one, if we wanted to change the color, we can do that. Give it a second and it'll keep thinking. And then what we could do now is adjust any of these parameters. So say maybe we wanted the normal map not quite as prominent, or if we wanted some of these edges a little more glossy, we could decrease our roughness. We'll give it a second to think. And there we go. And now if we did have this for other objects, we could copy it again, but for now we're not going to copy it. And we could change this to whatever texture we wanted. So I'm going to switch it actually. But before we do, I'm going to pause the rendering. So if we did our to rough wood, diffuse, accept, rough wood, here we go. And then also the textures here that we're using are from Polyhaven, I believe it is. The link is on the sticky note in the geometry context. But they have great textures that are free to use. I think this was our normal, wasn't it? Yeah, and then displacement. Rough wood, and we're going to do displacement. Yeah, so they're all here from polyhaven.com. So Karma XPU. Let it think. And there we go. We now have our wood. And if we wanted this to be regular wood color and maybe a little bit saturated with a gamma of 0.8 and a gain of this, if we let it think, there we go. And we can fix this by going up top to setting linear, which will just put it back to what we had before. And there we go. And we can change all these colors and parameters without having to dive inside here or recreate all of this again. So super helpful, and you can save lots of time. And this is actually a very simple one. We can get more complex, and we will actually later in other ones. So we'll be right back and go to the next section. All right, welcome back. Actually, before we go on to the next setting of displacement, I want to jump inside and show you that all of these are the exact same. So remember how we just created this material from our follow along and then modified it to create this wooden material? That's the exact same thing that I did for all of these. So actually exact same workflow. And I did one for the rebar concrete, for the sand here. And again, these textures are just from the, you to go up, the Polyhaven, but textures from Quixel would work really well. We'll probably actually use some Quixel textures in later videos. I just cannot distribute those. So I wanted to stick with ones I was able to share with the files so then everyone could follow along. But Quixel is my personal favorite place to get materials. And then again, all of these we can just flip through different frames and see what these materials look like in different lighting setups. kind of like that purple actually. It looks nice. All right, well, we're gonna keep going. You to go up, but first I'm gonna actually stop this render. You to go up, and now we're gonna jump inside our 0.4 example displacement. Again, very, very simple network. We have our primitives coming in, our floor and wall, our materials, and there's a few tricks actually we can do here to make this organization a little bit better. We could have put these in a different LopNet and then done a fetch, which lets us get a certain path. So this fetch, give it a second, is the exact same thing we have here. So we'll do that later when we're creating larger scenes, but if we wanted to put maybe the geometry in one and a whole material library in one, we can reference different LopNets and rearrange and organize different information in a efficient way like that. And that'll help also if we do more render layers. So also we have multiple ones coming in. Switch back to frame 1 to get that nice lighting, and then go down to here, and this is our displacement. So we did have displacement on the last setup we just put together, but if I zoom in here and go inside this, this is actually the pretty much same. I'm gonna take a snapshot actually, and then pause our render. So this is the same setup. I think it might be either a copy paste or maybe I just remade it, but the one we just covered, the one for the checker pattern, is actually a different setup, because here for our diffuse, what we do is we do a color correct. For the checker pattern, I did diffuse, brought it in as a color, but because I knew it was going to be the black and white checker image, again, I'll show you that here in case you're skipping around. Back up. I guess it's in textures. And then do tools, edit background images, and I can move that out of the way. So this diffuse image is our checkered grid blur. I brought it in, which is a black and white, which technically I could have read it in as a float. But in this case, I split out the RGB and then used the red channel to control this map, and then I remapped this from black to red. So the black would stay black, and then the red would become red. This will make the blacks the green, and then the reds could be blue. And then roughness, very similar, bump map. Actually, it looks like for this one here, I used a normal map, which is the, normal coming in as a vector 3, going into a normal map node. For checker pattern, I have a image coming in as a float, remapped with the float ramp into a bump. So same way we set up the background for the grid. And then same thing, I did a displacement and then scaled our displacement here. It looks like I did not use a ramp to remap displacement. But you could add that in if you wanted to do a float ramp. Add it in, and then if you wanted to promote that, what you could do is edit parameter interface, go inside, displacement, and promote that ramp. So you could do that if you wanted, and then if you wanted to organize it a little bit better, you could name that displacement remap or ramp. So perfectly fine way of working. You can customize these, which is the best part about Houdini, however you prefer. All right, so then the next part we have here is I'll actually show you on the checker pattern because this is a good example. I want to show you the tessellation settings. And then, so I'm going to disable this, and then we're going to recreate this one from scratch. Again, our display flag is down here. Jump inside here. On our checker pattern, whoops, we have our offset. So if I set this to 0, you'll see it will start to displace out. And if I set our scale to something a little bit bigger, you see it displaces out. And then if we set this offset, it'll offset the 0s and the 1s values by this amount here. So we set it to 1, that will scale in our displacement. And we can do this, oops, not that. If we want to, I accidentally hit enter when I was selected, so I went inside, so I'm going to go U to go up. So we can scale this if we want to displace in negative values or smaller or bigger, because sometimes you'd want to have an object surface here, but you want to displace it up and down. And then the tessellation settings actually. So if you notice, zoomed in here, the object geometry that is coming in is relatively low resolution. So all these individual grids are the single points and polygons on the actual object. If we displace these, so if I go render geometry settings, add it to our geometry, our scene tree, and then if I want to select the primitives I want to operate on, and I want to do all props. So props, all. You see now it automatically divides because our tessellation, which is redshift is tessellation, and karma, it is dicing quality. So if we set this to 0, that'll say keep your geometry incoming without any tessellation. So none of these points will be divided into geometry, but our displacement will still be applied. So if I set this to a greater value, maybe a 1, I think the geometry should still be applied. All right, I guess dicing quality of 0 disables the displacement altogether. So here we go. If we put our dicing quality very, very, very low, that'll essentially be no dicing. So no tessellation. I'm gonna put this back to a reasonable amount. U to go up. So we can see here, the resolution of the object really doesn't increase. So this low resolution object, can I do a snapshot? I can, great. So this low resolution object, and I just took a snapshot of the viewport so we could see, these single points in these vertices are being displaced, but because there's not enough resolution in between these points, the map, which has these grids, doesn't know what to do, so it just displaces these amounts, and there's this weird, wobbly, distorted look. So we need more resolution, more dicing on our object to displace this. And you can see we can increase these, and the bigger we set our value, the more tessellation we'll have. I think this is actually, okay, 1 micropolygon per pixel. So if you go higher on this, you'll get better resolution, and you'll see sometimes we might have such a crisp displacement as this little plus sign. So if we set this to 0.5 or 0.2, we won't quite have the same resolution on it. Looks like 0.2, we're still getting pretty good. All right, so here on 0.05, we don't quite have enough resolution to displace either of these. So if we increase that, that'll give us the geometry we would need to displace those. And you can go higher with this. I would only go as high as you need, because if you go too high, it will either never load in XPU if you don't have enough GPU memory, or it will initialize for a few minutes and then freeze and may crash. So do be careful with the dicing quality. And if you have multiple objects being displaced, you might want to tone those down individually and maybe only in the foreground have objects with high dicing or have no dicing and just normal maps. Another setting is this true displacement. So if I enable this, I can set this to bump map displacement. My dicing quality is too high, so I'm going to disable that. And I think 0.5 might be the default, unless it says it's 1. But what I was mentioning was this lets us see a similar effect. And in this case, it's not quite as obvious, but we can use a displacement map to pretty much do a bump map. So to fake it without having to add the actual displacement. I'm going to exit this out. And then for these other ones, this is a rock and a brick texture. Rock wall. Again, very similar setup. Displacement here. Looks like my displacement was off, so I'm going to put it back to true displacement. And again, this rock wall is this left one, so if I change our hue, it'll change the hue, and then we can change our displacement. And then rock B was this one here. I could also change the hue or change our U to go up. I want to change the displacement to 0.15. There we go. And if we could change our tiling, maybe we want very, very, very small bricks. And then again, the seams here are because we are UV unwrapping. So in this case, it's a little too high. 0.05 would probably be better for a displacement of this scale. So there we go. Got some nice displacement on our object, not too much, and we have enough resolution with that and the bump map. You see this normal image to give us enough detail on our object. Looks like actually the displacement's carrying a lot of the weight, which is awesome. So disable this. We could also do more complicated effects, such as remap this displacement to color inside the cracks, but we will save those for later videos. Awesome. All right, we're going to continue up with the next one, which is triplanar and noises. So we'll be right back in a minute and then get into the exciting stuff. Welcome back, and let's keep going. So next up we have our LOP Network 05 example triplanar and noises. Double click to jump inside there. And as usual, this is very similar to what we've had before. Actually, I'll show you this. I don't know if this cop network is in other, whoops. Okay, it is, and we just missed it. So I'll cover that because that might be something that you were curious about. But first, I'll introduce what this network is. So this is our 05 example triplanar and noises. And in here we have a few setups for our materials. In this case, actually, we have, whoops. All right, W again for wireframe, and I'm going to frame our cubes and our spheres. In here, we have materials that are mapped with without UVs, actually with triplanar mapping, which is a way where we can take the rest position of our objects and use that to generate coordinates for where these textures are going. So the world position has been saved to a rest attribute, and I'm going to click at these spheres and then I'll show you where that is saved. But actually these spheres, let me show you real quick, are just 3 different resolutions of the same sphere. So a very low resolution coming in from this side, a medium resolution coming in from the middle, and then a higher resolution coming in from the left, which would be this side of the switch, which I have selected right up here. So if I jump to where this SOP import is being, where the geometry is being fetched from, you will see a box, a subdivide, a UV unwrap to generate these coordinates. This was how we created our sphere, but since we're doing triplanar mapping for this part of the lesson, we're going to actually delete those UV coordinates, store a rest position, which if you remember from the beginning of the video, stores the world position and the normal into these attributes. And then we painted this mask, which was a attribute painted now to this mask attribute here. And then we have a null to reference this from our stage context. And in this case, it's the same object, same geometry coming in, but we subdivided to give more resolution. We store the rest after the subdivision. So then that way, each of these points here with the additional subdivision resolution can have their own rest position saved. We add another mask, which in this case, we tried to draw a little smiley face, but didn't quite get as much resolution there, so it doesn't look quite as nice. And then we have another null, and then the same thing here again, except I increased the subdivision depth to 4. So now we have a lot more. And then on our mask, I first painted the mask with an attribute paint. And then what I did, so here you select this, give it a second, and then if you hit enter, when you have this node selected, it'll take you into the paint mode, and you can hold down Control to erase. So I'm going to delete that. This is our mask that came in. Again, hit enter while you're selecting the node will let you see it here. And then that attribute I have blurred with an attribute blur. And remember again how we learned to preview our attributes. So ramp from attribute. This is coming in on the points, and we can see that here in our geometry spreadsheet, this mask attribute. And now on our color, we want class points, because that's the class here on our geometry we're looking at. And we want to read the mask attribute and remap that to a color attribute. So if we disable and bypass this blur, we can see what this mask is doing and then what this blur is doing. So just slightly blur the attribute and then stave it back to our geometry. So now if I go back, that is the setup we have here for those objects. And then this cop network, I'll show you quickly. I actually used this to blur our image. So I took in the grid inside here, which I used a file node, and then referenced hip assets textures. So I selected that, selected our grid, and then used a blur. And then this was a null for me to reference in the ROP image output. So if I want to save this, so save me, I would drag that to my cop path. I would set my render output file, which I'm going to copy this and I'm going to paste it here, and I'm going to name it. Actually, let's see if we can do some kind of change. Sure, we'll just do a value shift. Well, let's do this just to make it look a little bit different. And then we will save it to blur v2. And now if we click here with our render to disk, we should be able to do a background image load with this button at the top. Go to hip, which is assets, textures, then we should see our blur too. Double click. But what I did that to blur out the, I'm gonna X this out actually. Oh, I'll leave it there. I guess we don't, doesn't really matter. But I did that to take our image and then blur it for our normal map on the, or actually our height map, excuse me, on the background. And if you're interested in more cops, the fire tutorial on this channel, a not that bad approach to fire. We do render passes for fire, smoke, and embers, and then actually do a slap comp entirely in cops. So that's definitely worth checking out. But to continue, That's what the COP network was for. And you can also reference the COP nodes directly in textures. So inside here, instead of using a tiled image texture, you can reference these and reference the null from your COP network. But sometimes that reference breaks and you have to restart Houdini because the GPU ran out of memory. So a more stable way is to save those images to disk and then reference them back in. But let's keep going here. You can actually also see the camera I used for the thumbnail for this video. So I'll go to the bottom, go to Karma XPU, give it a second, and then we're going to review what's going on here. And remember, there's no UVs on this object. And you can even see our dicing settings are a little low. So if I disable this, it'll change the dicing quality. I'm going to refresh. And this was that displacement we had just covered. Because if I enable this and set this dicing to 0, no dicing, 1 will increase the dicing. So we'll leave it at 1 for now. I'm going to turn off our rendering by going to Vulkan. And this first material library is what we're going to dive into first. And again, with our switch, it's set there. So double click inside here. And now we have these ones. So this is similar to the way we'd set it up before, where we have a network inside here. And we'll walk through this node by node. U to go up. And I've promoted the parameters. I'm going to hide that a little bit. I've promoted these parameters to use, and you'll notice in this one with the normal, I did not have a normal image because I was using this grid. But you could edit this to, instead of having normal, maybe for this one you could use a bump map. So we won't do that yet, but that's an option you could do. But how this one's working, so again, all these settings are here, and I'll show you how to use this in the next one once we set it up from scratch with a material blend, which will be a lot of fun actually. But inside here, double click, we read in our attributes. So we use a primvar reader again. We read in our rest attribute as a vector, vector3, which if you remember, I will actually go, I'm going to try to find where we had that rest attribute created. So here, we created the rest attribute, and actually if I want to see the parameters, what I can do is hover over this one and click P. So you'll see we created this rest attribute. P will bring up the parameter pane, and that will bring it up just for this network view here. So we created this rest attribute, saved it to rest, and then normal attribute, we saved the normals to RNML. And that's what we're going to reference here. So rest and RNML. So rest and RNML. Same thing there. We then have a divide, which lets us scale the position. So if I go up, if I render, that's this triplanar scale. If I set this to 1 and give it a second to think, it'll change the scale of the mapping that is coming in. So if I set this to 0.1, that'll make it a lot smaller of a tiling for our image here. And the blend here is what is controlling the triplanar blend between the X, Y, and Z directions. So you see this blend here is nice and blurred a little bit and you can't quite see it. If I increase the blend, give it a second to think, this blending here will be less of a distinct cut and more of a smooth transition. So that's up to you, and then also on your materials, that might be a factor you can play with as you're setting them up. And that blend actually, if I double click this network again, it is this constant, which is a float. Remember our constant, material X constant. Our float is being brought in and set in the blend factor of our triplanar. So this is a triplanar projection. For the UV ones, we used tiled image, but since we're doing triplanar, we want to have a triplanar projection node. And what this does, it reads in a texture from the X-axis, the Y, and the Z-axis, And in this case, I've copied. So right click, copy parameter, and then right click, paste relative reference. And that says reference the channel string named file X, which if we hover here, parameter file X. So it's saying get whatever file is in the parameter here and copy that here. So if I middle mouse button, I can see what that evaluates to. And that is the hip folder. Your location will be different, but that's the folder on disk where it is being stored. And then that's the checkered grid blur, that we created. So same thing we've done before with the roughness, normal, displacement. Here our rest position goes into the position, and the normal, which is the RNML, goes into the normal here. This is important for triplanar projection. And then we have a ramp here, a normal map, which is again a normal map. Give it a second to load. And here we go. And we just plug that into in and then out into our normal. And then our displacement with the subtract, the displacement node, which we've set our scale in the output. U to go up. And then we'll recreate one of these later, but on a different example. But then if we wanted to create maybe the wood here instead of this grid, what we could do is we could take our bricks, maybe alt drag to duplicate, let's say our wood material, U to go up. I'm going to bring up this into our stage context with autofill materials. Our wood material is the one we just created. I'm going to assign this to sphere left. And these spheres, again, were created here and not with the operator string. I named them as sphere left, so then we can change the resolution, which I'll actually show you right now once we get our wood set up. So our wood material is being assigned to the left, it should be. Oh, not yet. There we go. Now it should be assigned to the left. And there we go. And now if we jump inside our material library on our wood material, you see right now it's this brick. And the reason we promote all these parameters is because it makes it really easy to change materials. So wood rough, let's do diffuse. Rough wood, I guess it's called. We'll let it think, and then we'll do rough. And you can select the JPEGs or the .rat files. The .rat files you'll have once Houdini has started rendering. It converts those textures automatically. So rough wood normal. Give it a second. And also, if you don't want 4K textures, you can go to the website. Oops. Let me do displacement first. That's not what I want to do. I accidentally renamed this. So I'm going to delete that to rename it back to high poly. I wanted to find this link. So P is going to hide this again. Polyhaven.com is where you can get textures from. And I downloaded 4K, but you can download 2K or 1K if you'd rather work with those. So wood material, and let's just change the hue just for fun. Looks like everything's set up except our diffuse, roughness, normal, and we need our displacement. Rough wood, displacement. Now it should be the wood, but if something goes wrong, we'll double check it. I'm just going to double check that we are referencing exactly, yep, rough wood. U to go up. Let's see, because that a second ago was the brick. All right, and now it decides to change correctly. So again, sometimes with Karma XPU, you have to force reset decrease this displacement. Looks like I'm going to decrease it by a lot, actually. It's 2.01. Because for this one, we don't really need displacement. For the bricks we do, but for wood, since it's a little bit smoother, we don't need it. And what I was actually going to show you now that we've changed this was the incoming resolution of the objects. So you go up. I'm actually going to go to our shader, all shaders wide, which is this camera I've created here. And you have to select a null below this camera, because remember, Houdini knows nothing about what's below, only about what's ahead, or excuse me, above. So I'm going to select our Karma XPU. I'm going to let it render. Then I'm going to take a snapshot and we're going to switch our incoming geometry and see what happens. So snapshot, switch, give it a second. I'll let it go to maybe 30% because it does look pretty clean here. This is why XPU is so nice. Very fast, actually. And then 3. Well, input 3, but selection 2. And then we'll let it think. And you can actually see, remember how we had a low resolution sphere coming in? You can start to see that actual resolution here being defined in the silhouette of our object. And you can also hear my computer fans going. So I'm going to turn off the Vulkan render, or turn off the render by switching to Vulkan. Color correction, aces, and now, right now exactly what we can see is this. I'm actually going to delete these old ones because we don't need those anymore. So coming in here, remember how we had multiple resolutions of spheres? These again have no UV coordinates, but they have the rest position saved on these objects. So inside our SOPs geometry container, so in the SOP context, we created that rest attribute and the rest normal and saved that to our object and then read that in our shader in our triplanar node with these here and these triplanar projection node. So you again to go up, and we wrote that information to our shader or to our object and read it in our shader. And now you can see the different objects here. So this is the low resolution sphere, the medium resolution sphere, which is this one here, and the high resolution sphere. So you can see the shape of the silhouette is reflected. And the dicing settings are another thing. So if I turned off our dicing quality to 0, which again is in the render geometry setting, and selecting the primitives I want to operate on, I'm going to change back to our low quality and we'll render. There's no dicing here. Let me actually make the displacement very tiny because I want to displace but not add resolution. And I'll go to the high resolution. Now you can see the dicing quality added resolution, and it still allowed us to displace with a low dicing setting. So right here was a dicing setting of 1 with our incoming, low resolution geometry. This is a dicing setting very near to 0 with our low resolution incoming geometry. So the dicing quality adds the extra geometry and creates that geometry at render time for our shader to then be displaced. And then this version here was with a very low dicing quality, so 0.0001. And if we set it to 0, it might actually disable displacement entirely. So I just put it very low for this example. But this displaces the existing geometry without adding new geometry, and we can see it still gets a little resolution, but not quite enough. And this also displaces the existing geometry, but because the geometry incoming is such low resolution, there's really nothing for the geometry, excuse me, to be displaced to. So that's why the dicing quality is so important, and the ratio of your incoming resolution to the dicing quality will have a very big effect on your overall displacement. All right, let's go to the next one. We'll see what happens. This one actually is using the rest position. I'm going to switch it back to our 0. These are using the rest position to input 0 up there. This is this input stream here, material noises. And we're now using our rest position. And this is again a very slightly different material I set up. And the reason I set it up like this is because I'm sourcing everything from this single noise. So if it lets me zoom in, it's my dog downstairs, excuse that. All right, so here we have our object, and now I have this rest position, which I'm dividing to do a scale, which can let me either increase or decrease the size of our position coming in. I use a noise, a unified noise, 3D. I plug the rest position into the position of the noise, and then I've promoted these parameters in the same way we did the edit parameter interface and dragging and dropping, which we will create this later in the video. And I promoted all those parameters to be able to control that without having to dive inside here. I'm going to save the snapshot and then switch back to Vulkan. And then I take this output, which you can see is a one-dimensional value, a float. And we can tell because of this light blue color, I remap that to this color using a color ramp. And then I take that color, remap it again to get our base color. I use our roughness. I'm actually going to organize this way. I use our roughness to remap that to get our specular roughness. In metalness, I do a very similar thing. So if I plug this into our base color, we'll see the blacks and the whites, and that, whoops, U to go up. I accidentally jumped inside here. And you can see all the nodes in Houdini are made up of other nodes. Double click, which is a really cool thing. So you can dive inside and explore more nodes. But right now we have our white and our black coming in. In this case, the black is being remapped to red, so 0 here. And then looks like gray colors will be remapped to this darker. If I connect it, we'll see. See, black was red, base color. And I can change this noise, this remap, if I hit U, the parameter, excuse me, I've promoted is living up here on our parameters on this upper level. Same thing for metalness, roughness, and then the same thing again, but I actually did an invert to do a little bump map. And then this was for our displacement. So then I subtracted it and did a displacement. And the way those are all set up is if now I change the frequency, let's do 6 and 2. Of our incoming noise, everything is following along that. So always will have these dark, deep pockets of these grays, and the outside metals will be the greens, no matter what size of texture I use, even if I did 112. So very, very small. 600 is a little too big or too small, but you can see how you can also adjust these to get different effects you'd want, and noises are really powerful in Houdini. Whoops, I accidentally went below the floor. So let's go back up and let's set it here, and then we'll move on to the next material. You see this noise is now so big that it happens to only catch one part of the noise. If I change it to 0.6, that will let me get some different areas coming in. And then noises have also octaves and lacunarity, which is the ratio for each octave of how differently the detail in the noise increase, which is only for fractal. So if you type in Perlin, you'll get a different noise and therefore a different result on your objects. And you might have to tune the parameters here to get a useful result. But for fractals, so if we set this to 2, there'll be fewer levels of detail to the noise, so we'll get a more organic look. And if we set this to 15, we'll see all these additional details in the noise which are being generated. So all this detail and these cracks and all these roughness values inside here are because of these octaves in the noise. And if we switch this down to 2, it'll be the smooth value without that detail in there. So I'm going to turn that off our render. And then our next example actually is an alt drag again, oops, of the material, and I just changed parameters. So this one I did a little bit of a blue, and then I scaled the frequency of the noise. And then I actually removed the, looks like the metalness, whoops. I only kept, I'm going to zoom in a little bit more, on the very edges. So this outside blue is not metal, and if I did want that to be metal, what I could do is this very much left one. If I drag that down, and now that will make the outer edge metal. Same with the roughness. If I increase this here, and there we go. Now it's a metal, but it's very rough. So understanding how noises work and how values can be remapped in Houdini is very critical to fully unlocking everything you can do in Houdini. Next one, and then again, these are all the same exact material, and I'd recommend you break these down. We're not going to go into creating all of these just because that would be a little repetitive, but if you are interested in that, then I would download the files and then dissect them yourself, and you can see exactly how they're all set up. So this one again, I'll just take a screenshot and then let my computer take a little bit of a break. Or a snapshot, not a screenshot. So again, right click, color correct, and then I set to aces. So this one here, I had the outer values, these darker values, I set to green. Then I had a gray in the middle. Then I had another green, which was this middle value of this noise, which I remapped to this lime green. And then I had this darker gray, I guess lighter than this other black, on the very inside. And then for roughness, the outer edge, I had not quite as rough. And then the inner edge, which was this inside here, I had more rough. And then same thing for metalness. I only wanted the outer green to be metal, and then I wanted the inner, which is this half of our metalness ramp here, to not be metal. And then displacement also was the same noise value, but then I displaced blacks on the inside here, so they go down, and then these would go up. If I reverse this, actually, let's just see what happens. So it does invert our displacement. Oops. And that here is why these scales and offsets are really important. So you can offset your values, and then you can change or normalize or correct any of these. All right, on to the next one, but I'm actually going to cut real quick just to let my computer sit for a second. All right, welcome back. We're going to keep going, and we're going to jump inside this third one, which again is index 2. If I render, we'll see here what happens. All right, we'll give it a second. All right, there we go. All right. Oops. So yeah, this was a little more of a complicated material actually, but this is probably going to be more what you will be using on standard projects. So this is actually the thumbnail materials that we had set up. And then I will walk you through quickly how to use these. And then we can get into how they're actually built. So I'm going to pause this actually and jump inside this next one. Okay, this is actually the same one. So I'll show you really quickly. This one here is this stream here, and that's these materials being blended between by noises. So the same way we had this noise here being generated from our rest position, you to go up inside here, actually material blended noise, we have noise settings here. I'll jump inside here. We'll go through this node by node, so don't be intimidated. It's actually very simple material. But we have, again, our rest position being read in as a noise and then remapped to this mix factor, which lets us blend between material 1 and material 2. And then some additional controls, which we've seen a few times before. So I'm going to pause the render. You go up. Then if we switch to this next one, we'll still jump inside these materials. This is the same setup. And again, some of these spheres don't show in the shaded scene view. This is the same setup, but instead of a noise to blend, I read a attribute, a mask attribute, and then I remapped that attribute here. So remember these faces that we painted earlier on our objects with the attribute paint, I read that attribute in here with the primvar reader. Our primvar reader, give it a second, and I just selected our float and type in mask. Same here. If I connect this, nothing will change because it's reading the exact same attribute. And again, that attribute has to be created on the geometry. So I'll connect this. We'll go U to go up, back here, and then again, we'll look at these all together. U to go up, and then also I do have the switches here to control. So if I take a snapshot and then switch to input 2, which is our low resolution sphere, you can see here the object still has the blending. I'm going to set our dicing back up to 1. So it still has the, whoops, not CPU, material blend, but there's not enough resolution in the mask to get a clean representation of what we were trying to paint. So this is similar to vertex maps. I think Blender has them. Cinema 4D does have vertex effects. I know you can do a lot of those. So if you did want to do a geometry based blending, you can do that here. And you can see it does still dice and split up our geometry because our dicing quality has been increased. But that mask value has not been created on enough geometry resolution. So if you did want to actually use this, maybe you could leverage this to create a soft blend. Or another thing you could do is blur your mask attribute with an attribute blur. Whoops. Again, not CPU. Give it a second. And we'll see the face coming through a little bit better because there's more geometry on this object and has more of a resolution for our mask we painted. There you go. And then 0 again would be our higher resolution sphere with enough resolution to contain a good amount of detail on the mask. So that you can see. And these blending, you can create these masks by hand. So maybe if you did a path along our object, and we'll actually be doing that later, maybe painting a little path through a forest or some kind of setup there. So I'm going to go back here to 2, select our noise blended materials, And then we're going to jump inside and first recreate one of these for a new set of materials by copying and pasting, and then explore a little bit about the actual settings we have here, why I set them up that way, and then how to create a similar master material, we'll call it, from scratch. So these settings again are the similar ones we've done in the actual setup. If I hit edit parameter interface, it's the exact same setup. It's just a little more in depth because there's more material parameters we wanted to use, and then the organization here has been modified to make it a little more readable. So you're also welcome to use these in your own projects. So please download and break these, mess them apart, and learn from them, because that is a very helpful way to learn. But awesome. All right, we'll be right back, and then we'll dive into how to apply this to a new object and then dissect how it was put together. So that's gonna be a lot of fun, and we'll get to that in just 1 second. All right, welcome back. We are going to continue just where we left off and actually apply the current render, or not, excuse me, not the current render. We're going to duplicate this and then apply it to a sphere again, but we're going to use a new material. So we're going to see how this kind of works and operates, and then we're actually going to recreate it from scratch. So I think it's going to be the most helpful part of the lesson. So definitely pay attention and follow along. So let's choose one of these to replace. Actually, let's add a fourth, because I kind of like seeing these here. Let's add a fourth, and maybe we'll put it right in front here, and we'll call this material noise blend D. And then to check what we're doing, let's set the hue. Let's modify the hue, and we'll just bump the saturation up for the sole purpose of being able to clearly see what material we've applied to the sphere once we actually do apply that. All right, so we're gonna add in just for the high resolution sphere, because we don't need all these different resolutions for this part of the lesson. So I'm gonna alt drag and duplicate this. For this sphere, I wanna rename it to sphere new. Remember, our import path prefix is not the operator string. I've manually renamed it here. And then I want to merge this. And where do I want to merge it? I want to transform this one to right in front here. So let's do 0, 1.5. Oops. There we go. That should be fine. And then remember, sphere new is what we named it. So I'm going to Control S to save. And we'll go down into this one, which is where we just were before. I'm going to color this actually so we can better recognize where we were. And what we want to do is we want to bring up the one we just made, which was our material noise blend D, and then we want to assign that to our sphere here. So let's do sphere new. So assign the primitives here we want to apply our material to, and then our material. And now you can see it is applied. And if we render, we should see it probably more saturated than the other ones, because that was the change we made to get our material a little more visible. Remember, material noise blend D, and we added or offset the hue to change this color, and then we increase the saturation. And that also does look kind of cool. But we're going to mess this up, and we're going to find a new material to blend in. So let's disable this, go to material noise blend D, and let's change out this cracked mud. Let's switch it out for a different one. Let's do rebar reinforced concrete. And if you want to mess with these, you can use the same texture files, or you could go to polyhaven.com and download your own ones. So that'll be fun once we start putting together scenes. Oops, I don't want mud cracked. I want rebar reinforced. But that'll be fun as we put together scenes. We'll go through, pick out materials, blend them, and then we'll also do the roughness for this one. We'll also blend multiple material maps. So we might use a roughness map from maybe the dirt, and then a color map maybe from bricks, and maybe we'll create a new material. Let's do reinforced rebar concrete, and we want the normal map. And then we want the displacement map. Rebar reinforced down to displacement. Accept. And let's render this and see what happens, but we'll change our saturation back down to 1. This will only change the inside material because that is material 1. And another thing I actually set up, so I set up separate controls for material 1 and 2, and then a global control for both. So if I set right now the saturation for material 2 to 0, I can increase the saturation on material 1 under our diffuse. You see with textures, material 1, open that up, diffuse. Under controls, under diffuse, I can increase our saturation to something very, very, very saturated. And now I also have a global setting, which I set that controls both of these. And the way that works is I have some saturation controls here. This is for one of the materials, looks like material 2. And the top one, I believe, is material 1. So I have some color corrects, the ramp, multiply for the displacement, so we can control the scale of one displacement, the scale of the second displacement. We merge those, and then we have a second offset and a second scale to control those together. Same thing with the color. We have the diffuse, the color, diffuse, and color, and then we merge those with our mix, and then we have a global color that lets us change color for the entire material. So we're going to bring this back to regular saturation for material 2. We're going to change the scale to make it tile more. That looks like it's a lot, so maybe we'll just put it to 0.4, 0.4, 0.4. And then again, the noise blend settings up here, so I can close down these materials for the settings, or settings for the materials. And if we changed the frequency of our noise, we can remap the noise values, and that will give us a different result here. So this would be helpful if you're blending between materials and want some ground that doesn't have as much texture repetition or tiling on the images, or if we wanted to control based on other factors, such as a path we could draw and then measure distance from the path. So maybe the path is dirt and other areas of the path are rock or grass, and we can create noises and masks to use in that. So now I'm trying to remap this just to get a little bit different look. So I encourage you to mess around with this. This is a basic material, but we could even add more if we wanted to, and we might do that later to have multiple ones blending, or if we wanted to create even more complex material setups, we could maybe blend normal maps and height maps or colors, or add noises to the colors to give different variations. So maybe we wanted different parts darker, some random noise, some scratches. Maybe inside these noise puddles, we could put a dirt texture and have it be reflective puddles on the ground. And then again, we can change all these settings. So maybe put the saturation a little lower, and maybe our texture on this gravel, this sandy gravel, needs to be remapped to a little bit smaller. So there we go. And if we wanted to put bricks, maybe we could change the, let's actually see what material B is. So if we wanted these red bricks, which I think is rock wall 8. Yep. I'm actually going to paste these. So I'm going to take the diffuse images from here and I'm going to put it on our diffuse images for our material 2 on our noise blend D. So again, I'm copying the normal here and I'm going to paste it in the normal. I'm going to copy the roughness from material 1, which was that brick one that I liked. Was it? Maybe it was 8, material 8. So we'll just select it manually, I suppose. But we could copy and paste if we wanted. Roughness. And this one was normal. And this one was our displacement. Now let's see if we got our brick material to replace this. Looks like we did, but if we wanted a different hue, which looks like it was set to 0.926. So if I did 0.92, should give me the reddish, hopefully the reddish color, which it is not. All right, well, let's try to get one that does look red. All right, it looks like I'm also getting a error from Karma. So I might have to restart Houdini to clear that up. All right, well, let me get that cleared up. But let's see. I actually do want to figure out that red. If I set this hue back to 0, saturation so bright at 3, maybe it's the gain. All right, well, we're going to figure this out. Oh, okay. There we go. I'll leave that in because that was a little bit dumb of me. But we are all making mistakes too. What happens here, and I should have caught that, but I guess that's why we are learning together. What I had was I set a hue here on my material 2, and I was confused as why that wasn't setting it to the right value I was expecting, but it looks like up in our global settings here, I was overriding that hue. So again, to show you what happens, and then I'll reset my Houdini to get rid of that viewport. I set the hue once in here on my color correct. Maybe it was up here on this material too. But I set the hue once. I was expecting it to be the red. And then it was later set by this one. So the value that I put here for material 2 was set to a certain value. And then in the global settings, that pretty much changed it. So if I put this back here at the bottom, 2.92 for hue, that will probably make it blue. And then if I put my global hue back to 0, hopefully that'll bring it back. And let's increase that saturation again. Okay, there we go. So even I get lost in a material network that I set up myself. All right, so this is now one error, and I'll open this up to see what happened. So maybe you can see if you have the same error, and maybe I could just restart. So to see the log viewer pane, we're going to open up a new pane type. We're going to go down to log viewer, and it looks like some XPU failed when I was reloading. All right, so what's going to happen is probably just a restart of Houdini will fix it. I'm going to do a test here to see if I can do it live. Otherwise, I will do a cut and be right back. So when I'm switching to CPU, will force your XPU to reload. So I'll give it 1 second. And then I will stop the render, and then I will switch to XPU and see if it went away. Most likely it did not, in which case I will restart. Then I'll leave this all in the video because it's going to be helpful to see that bugs do happen. Okay, so it looks like the error is still there. We could probably continue and it'd be fine. Welcome back. Actually, one thing that the issue might have been caused, and I'll leave this in because this might have happened to you accidentally in the scene files, or it might be good to know. In our log viewer, sometimes XPU does have a error just randomly when we're working. So sometimes refreshing it is the way to solve it, but it looks like this is trying to load a texture. Again, log viewer, you can get up from here, new pane type and log viewer, but it looks like this is trying to load the texture that is named 5k.exr for our normal map, and we do not have a texture named that. So I must have accidentally typed in the normal map incorrectly. So to fix it, I can actually go here and just type 4K, because that is a texture that does exist on disk. And we'll see if this works. Oops, I don't want a scene view there. Restart. And if that didn't fix it, then it might be referencing it in a different material. Double check. All right, well, that looks like it fixed it. All right, so it wasn't the restart of Houdini. It was a texture error that was being named incorrectly. So I'll leave that in just because that was a mistake I made, and it is helpful to know, but you should be aware of that. And this also does give you some errors. We're going to avoid some of these for now, but this will be helpful later. All right, well, let's keep going. I think the next step, is going to be probably creating one of these materials, actually. Master materials, we'll call it, from scratch. So I think a good one to do probably would be actually the Triplanar noise blended. And I'll show you one thing actually really cool that you can do with that. So say we had any kind of input geometry. This is a test geometry in Houdini. And the reason it's a test geometry is because you can test things with it, like we will do right now. So this is the cool thing I'm going to show you about triplanar textures. And if you've used 3D before, you're probably aware of this, but for those of you new to Houdini, or for those of you a little more new to 3D or unfamiliar with triplanar textures, this is going to be the cool thing that we can do. So I'm going to use another attribute delete to make sure we do not have any. I'll copy that from here actually. So this is just an attribute delete, and this is a node again that lets us delete specific attributes. In this case, we want to delete the UVs, which come in here by default on this test geometry. and we're going to delete those from the vertex. So here we got UVs coming in on our geometry, and we can see with this input here, and we're deleting that with this attribute delete. Then we're going to subdivide it, maybe only one time to add more resolution. Then we are going to store our rest position, and we will paint a mask. And I'll actually delete this and show you how to do it. Attribute paint, just in case you're doing this on your own project, because hopefully you'll be learning enough about Houdini to start creating your own stuff. That's my main goal here. So let's do just a little bit of painting here. Again, that comes in as our mask attribute. We blur that attribute. You can't see it here. And then we'll select all of these, hit A, drag to arrange, and we'll name this out pig. And our mask attribute is on our points here, and our rest normal, which we added with our rest node, rest position. And again, you could do that in a wrangle, but we will do it here. You could also do it in VOPs. That's the cool thing about Houdini. All right, I'm saving the file, copy, U to go up. I could have actually hit the back arrow, but we're going to jump back and do the LOP network we were just working in. And instead of this sphere, let's bring in our pig. There we go. And now, because we didn't change the prefix path to operator string, that's going to bring in the pig as the same primitive name as what we had in our sphere. And the nice thing about that is when we do our transform, you see it's set to transform anything with sphere, which will move our sphere. And then when we assign the material, that's assigning the sphere new, which we brought in our pig head as sphere new. So if we open it up this, I'm going to click down here so we have our dicing settings set. We will see our material on our pig head. We'll let it think for a second. And it's material noise blend D. And then we'll let it clean up a little bit, and then we will create this from scratch. So there we go. We had our material come in, our pig head. We saved our rest position. We read that rest position in our material network. Looks like I actually did label material 1 and 2. We read that in our material network. We have lots of controls here to edit and modify these, and then we applied this texture, and now we have some great geometry. So this is cool if you want to do big scenes or environments. You can use this for rocks, foreground rocks, background rocks, or quick shading for pretty much anything that doesn't need to be super close. And even if it does need to be super close, you can add some more resolution in your shader or some extra tricks, which we might learn later. All right, well, to continue, let's recreate this from scratch. And I think for the best learning, I think I might just recreate the entire thing. So that might take a little bit of time, but it'll be good to learn. And then also learning how to organize these, if you are new to Houdini, is going to be super helpful, because then you can create your own materials and then learn how to kind of organize these and then save these out to your own projects, which will be a lot of fun. So let's say this our new master material. And again, same way we did it before. Let's give a bold, unique color. We'll go up, autofill materials to bring it in from our material library into our stage context. In our geometry path, we're going to add, whoops, not our geometry path actually. In our material assign, we want to assign this material to the pig. So we can actually also do that by this, dragging and dropping, but then we'll have not quite the best way to do it. So I actually like to drop it in here, but it could let us do that. And I might create a new material node. Well, let's do assign, and we want it on sphere new. So I don't like to do the dragging and dropping because I like to know exactly what's going on. But if you'd rather do that in your scene, you're welcome to. In our material, let's jump in and let's get started. So what we want to do is we want to have, let's do a little organization. We want a material 1. Can change the text size with this here. We want a material 2, and then we want some blend settings. All right, and now we're going to set up this whole material and then promote the parameters after. So let's do triplanar, and the way to do non-triplanar would be to do the same way. Oh, I'll find it and then I'll show you really quickly. The same way we did it with the tiled images. I'm going to show you here. And the same way we set up the images for our background, which it's going to be cooking the geometry attributes again on the shader ball. I probably should have cached those actually, but we won't worry about those now. So inside material example, inside here we use our tiled image. And one other thing I can do is I can hit Control 1 to set a quick mark, which will save this location in my networks. I'm going to hit the OBJ to go all the way back up. I'm going to dive inside here, and we'll color this green. Dive inside here where we just were. I can hit Control 2. Now if I hit 1, it'll take me back to this network. If I hit 2, it'll take me back here. You can do that with any number, with again Control and then the number, and then you can jump back and forth. So that's a little helpful tip. So let's try to do this quickly. Diffuse 1, and we'll do roughness. Let's say 1. We'll do normal 1. Do displacement 1. Diffuse, we want a color, so that's fine. Roughness, we want a float. Normal, we want a vector 3. Displacement, we want a float. Diffuse, we want to copy parameter, paste relative references, which will paste that value. So if I said AA or SSS, it copies SSS. And another way, since this is being referenced on its same node, so CHS file X is referencing the parameter on the same node, instead of doing the right click copy parameter and right click paste relative references, I can just copy this string, paste that, and it will be the same value. So I'm going to delete that SSS. You see middle mouse button is like this. And now again, because we're working on the same node in our roughness, I can paste this and paste this. And that will reference the same channel. And because it's relative path, it's the same relative path here. It's just on a different node. So I'm going to do that again. Paste, paste in our file Y and Z. And now if we change the X, it will copy that string. So paste, paste. There we go. Now we want to do, let's set up our rest attributes first, and then we'll copy these. So I'm going to color these blue for material 1, and I'm going to cover these yellow for material 2. I'm going to do a primvar reader to read our primitive, well, not primitive, but primitive in USD. It's a point attribute in our SOP context, in our geometry context. We want to read the rest, which is a vector 3, so an XYZ value. This is our blend, so let's put these in the middle. Color these green. And I'm going to organize this a little bit better. Then we want another primvar reader, and we're also going to read a 3 vector, vector 3. This is going to be RNML, rest normal. Now what we want to do is a divide. You could also use a multiply, but that would just invert your the values. So instead of typing a small number, you would do a multiply by a big number. So here we're going to divide. This is going to let us divide our rest position to essentially change the scale of our textures. We're going to say this adjust scale, and then our rest normal will be fine, but we can do the scale applied up here to position, position to position, position to position, and we'll also apply that for all of these. Actually, since we want to be able to control the scale of each material separately, maybe we want big bricks on one and small bricks on the other, we're going to do a little bit different. So we're going to copy this to have two different scales. We're going to have one scale for blue and one scale for orange, and the normal is going to be the same because we are not changing the normals. We just want to have the option to remap the scale for the different materials. So again, if we wanted to change one of the materials without having to change the scale of the other, that is where this is going to come into play and be helpful. So position, oops, not normal, Control Z to undo, position, position, position to position, double check they're all connected, and normal. Again, since we don't need to actually adjust this on a per material here basis, we can use the same one coming into both of these. And I'll put these here so it's a little bit out of the way. Normal, 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 normal. Awesome. All right, now we have that set up. The next setup would be to get our materials probably connected, but let's do our file paths first. So in order to set those up, let's promote them, and then that way we'll add those in and we'll be able to control them from the outside. So again, to promote them, I'm going to go U to go up. Organize this a little bit better. U to go up. On the material I want to be modifying its parameters for, I'm going to select the network, go up to this gear icon, edit parameter interface. Now we get this one here, and this material X builder is this drop down right here. So we're going to add a new folder under the root. We're going to make it a simple. We're going to say master material controls. Again, it's a master material because in Unreal Engine, I use that a lot, and master materials are really, really fun to use in Unreal. We might actually get to some Unreal stuff later on this channel. So if you are interested in learning Unreal, I could do a similar series on that, but Houdini is going to be the focus for the foreseeable future. All right, and now I want to do two folders actually. I want to do one for material. Let's do collapsible material 1. Let's do 1. And a material 2. 2. Collapsible. There we go, 1 and 2. And then I need a global. So we're going to have some global settings, which will be maybe the color correct for both of these combined, or maybe the displacement scale after we've merged together the displacement. So global, and I'm going to set them to simple. Okay, I'll set this to collapsible. And then we also want maybe, I think that might be good actually for now. Oh yeah, okay. Well, we'll set up that now, but when we add our noises, we're going to need to do another map for generating the noises. You see here, we use another rest position, and we have that up here, and then we put that in our noises. So let's actually make that set up now for collapsible. Let's say global noise. then actually, since this is a global, let's put that under our global folder and put that above. And then in here, we'll also have a few more, but we'll add them as we need them. So apply. Nothing's going to be here yet. That's because nothing's inside. So let's start with a color. Actually, what we wanted to do was bring these inside here. So I'm going to do 4 more folders, not the file. Whoops. I'm going to do 4 more, and we're going to have diffuse. Whoops, not that one. If I can type, we're going to have rough. Actually, let's do them tabs for this time. I'm going to delete these actually to make sure we're getting them the right way. Tabs, so we'll say diffuse, diffuse. We're going to do roughness. I'm not sure why that's being marked down, but we'll leave that for now. That's not important yet. Roughness, normal. And we'll do a displacement. And then we want these ones pasted. So Control C and Control V. And then under diffuse, material 1, put our file. For that, again, I just drag and drop the X. For roughness, you see it's already linked, so it's going to give me this warning. Roughness, I'm going to put the roughness file. We'll say file, roughness, and then I won't rename these just to save time. File, diffuse, normal. I'm going to put this one. And one thing to note actually, because there's these A's here, I believe that's going to set the default value of our displace a C. I can't think and type. I think it's going to set the default value of our parameter to whatever that was typed in there. So I'm going to continue and then we'll see what that does. So file, diffuse, roughness, file, roughness. We'll do file, normal, and then file, displacement. And then for the displacement file, I'm going to rename that to file displacement. And then what I was going to say was our default values. You see, file roughness AAA. And the nice thing about the tabs, actually, that might have been a little bit easier to see than all these drop downs. So maybe tabs is a better way to do it. And if I set these also, the diffuse, roughness, normal, and displacement to simple, it'll set it to what I had before. So tabs is actually a lot better to work with. So that's good to know. And you can just make your preference, your choice on how to do this. But again, file roughness, AAA, file roughness here. If I want to change that default value, I can go to menu, or not menu, channels, and that's right now by default. I could say image goes here. Apply, image goes here. Now that would not give you any values if you tried to render that. That probably would throw an error. So you could probably leave that empty, which would be the better way to do it. But you could put that there if you'd like, or leave whatever you'd want there. But I'll leave this for now, actually. Jump back inside, and then let's add an HSV. Guess a color correct here. And in cops, it's an HSV adjust. So we'll do this one. And I'm going to duplicate these before promoting them. And then float ramp for roughness. Float ramp down for roughness. And then I want a normal map. And the way we could do this for these is we could either bring them in and then blend them and then put these in here. So we could merge these and then blend and then combine the normal map. But I'm going to combine them with the normal map first with this node so that I can manually adjust the scale of the intensity of each normal map independently. Vector 3. And I'll do a float ramp again. I'll just alt drag to copy here. And then I also want to subtract, which is an offset I want to be able to have for each individual displacement. And I don't want that, so shake. And I want to do the displacement subtract. Again, I want that on in 1. There we go. Looks like a ramp, we forgot. It's funny, we say we, but it's me who's doing it. But, all right, there we go. Ramp, subtract, everything's set there. And for the blending, let's first promote our parameters actually, and then we will set up that mix. So again, we want to bring those parameters up to these tabs here. And the way we'll do that is we'll dive inside, go to here, and we'll drag whatever we'd like. So maybe the hue, the saturation, gamma. You can drag more or fewer of these depending on what you need. Normal map, I'm going to do scale, apply. Displacement, I'll do the ramp. We probably don't need to use the ramp, but if we wanted to invert the displacement, we could flip the ramp here or do it however we'd like to control that. Color, I'll add the hue, the saturation, the gamma, and the exposure. Apply. And then you see once I click apply, that sets these up here. And this dot dot again is referencing one level above where this current node is. So up here. And that's different because our channel reference here does not have a dot dot. So that's saying, hey, on the same node without jumping up an additional level. So color correct, I just put those all there. We want our roughness to have a ramp. We want our normal map to have a scale. We want our displacement to have a ramp and a subtract constant. And let's rename the ones that are going to be useful for renaming. So starting with the bottom, displacement, I'm going to say that displacement, actually, I'm just going to say offset because up here inside displacement, we'll see offset. So we can kind of assume that it's for the displacement, which is a safe assumption to make. But if you didn't have them organized, you wouldn't want to have all these parameters not named, but because they're in tabs, I would say it's fine for this just to be named offset. And then let's put the scalars above the ramps, just so we're not getting any odd things there. We'll leave that as offset. We'll change this to remap. We'll change this to remap. And then again, I would do these, but to save time and make sure you're not watching me type over and over and over, I'm just going to leave the default names. This was offset, scale, ramp, remap, and that should be good. Sweet. Awesome. I'm going to keep going. I don't want that flag on. And next up, let's do our noise for the blending. So let's get our rest position. Let's do a divide. Let's actually try to do something extra crazy. Let's set it up first, and then I'll show you another trick that might be actually a cool thing to use. So rest position comes in, divide, just so we can adjust that rest position. And then we're going to do a noise, a unified noise 3D. We're going to put that into our position. And let's do a ramp, because we might want to flip or adjust this noise. And that will be, let's say, mask. And we'll color these green. And then let's do promoting these parameters, and then we'll connect them all. So where do we want to put these? They'll be inside global and inside global noise. Dive back inside here. I'm going to promote the name. So rest attribute name, because if we are having maybe multiple rest positions saved, which we could actually do and might be helpful later, rest scale, we could say maybe rest A, maybe rest B, and multiple settings for that. And we'll promote noise type. And then these settings here, octave and lacunarity. Apply, up, and now see inside global, we have our noises. Let's put our, well, we'll leave the rest attribute name, because technically for our noise, that is the rest attribute that's being sampled for creating the noise. All right, next up, let's do the blending, and then let's connect them, and then we'll see if it works. So I'm going to do a mix node. Two, three, four. I want to mix color correct. And I'm actually going to color all these blue above and all these orange below. And I'll color these a pink. And then I want this to go foreground, this to go foreground, this to go foreground. Background, I want this. Background, I want this. Background, I want this. Background, this. And then mix, we're just going to do the same mix. Now we could plug these right in, but remember, whoops, we wanted a few global settings. So let's do another folder. Let's do this. Global noise we can leave first maybe. Let's do these as tabs, because that was a kind of a nice way to work. And then I'm going to do the hue. Actually, let's name this. I'm going to delete that hue. This will be global color correct. Apply. And I'll do another one for global displacement. Tabs. Apply. And then I'm going to put the color corrections, whoops, not there. I'm going to drag these underneath our global color correct. Apply. Let's do the exposure maybe too. And then I'm going to do a multiply. Actually, I don't need a multiply. I'll do subtract, because our setup here needs an offset. And our displacement has a scale. And then let's connect the color to base color. Our roughness, which was here, let's name these as well. And displacement. And this one, roughness again, is going to go specular roughness. And normal is going to go geometry normal. And there we go. Apply. You to go up. Accept. And let's just see how this works. So I'm going to select a texture. I'll just use this one because it was the first one that popped up. Rock wall 10. I'm going to copy the beginning part of the path, paste it, and go for our rough. Paste it. Go for our, whoops, normal, and I think it was rock wall, wasn't it? Rock wall, yeah. And displacement. And we want disp. And for material 2, let's do, and you see this changed it because that was not the default. So you could set a default material if you wanted to store a specific one, but for now we are fine with this. Let's do maybe the gravel, sandy gravel. And then also the result of your textures and how your materials look will depend a lot on your textures. So Quixel, I know, does have some great ones, but we are going to use these for now because I'm allowed to include those in the project files. And I like that because then when you download the files, you can actually start without having to add your own textures, and you can follow along pixel for pixel with what I'm doing. And I think I'm doing the right one. Gravel, 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 gravel. Let's do a hue. Oops. Don't know what happened there, but we're going to keep going. Looks like hue is a fraction. And then if we render this, hopefully we'll see something that doesn't look terrible. And there's a chance and probably a high likelihood that something got messed up. So we'll fix those together. Rest. There we go. That's a good sign though. So now our global displacement we can change. 0.001. Let's change our noise frequency a little bit higher. And now we could change our rest scale or the frequency. Technically that would have a similar effect depending on which way you scale them, but we'll be doing this because we might want to change them independently for some reason. Hopefully Houdini lets me continue working. And we should have a rest scale both for material 1 and material 2. All right, well, let's hope we can continue working. Otherwise, if it cuts, maybe Houdini needs a restart. So, okay, there we go. All right, I'm going to save it just in case, and then quickly check before we render actually. I thought we had a scale adjust, which we did. Looks like, okay, it looks like this is actually for the noise, which I should have known. I'm going to do a scale adjust for material 1 and 2. And to do that, I'm going to drag our divide here under material 1. We'll say this adjust scale. And then in the second one, I'm going to take the divide and I'm going to put that here and I'm going to name that adjust scale. This again is going to let us modify the coordinates of our textures without having to go inside here and then let us do those independently. And then this scale is going to be the noise, which will affect the split between the textures. So which part of the material is which texture. And we should actually have a ramp, which we do have, but we have not promoted that. So we want some harsher, some more straight and higher contrast blends between the materials. So inside our material here, I'm going to take the mask here, which was our float ramp, and I'm going to put that under global noise. Say remap noise. And then you to go up, apply, accept, and I'm going to bring these closer to have a better transition between the two. And then if we render, we should see, hopefully, this blurry mess tighten up just a little bit. And there we go. All right, and it looks like our gravel hue is off, and maybe we could scale it to a little bit different of a scale. And then I don't actually think our displacement is high enough. So let's change the displacement. And if this isn't working, then we probably need dicing, which it should have. And there we go. I just needed to think. All right. So this is a similar effect to what we had before. We've got our displacement, which looks a little too high now, and then our rocks. But I'm going to try to fix this and clean it up a little bit more. So first, I'm going to change the scale of our noise. Next up, I want to decrease the displacement on the sand material. So let's do displacement. The value, it looks like I don't have a parameter just for the displacement on material 2. I do not yet, so let's do that. Let's do a multiply. And this is another thing. As you use and set up the material, you'll see, whoops, new things you need to add, and you can add those as you go. So currently 1 and 1. I'm going to go to down here, this one, and I want to drag this to material 2 displacement. I'll put that up and I'll say scale, apply, and this one, material 1 displacement, which will be right here. Should be there. Yep, there we go. Scale. Scale, apply, accept, U to go up, and now we should have a separate control for displacement, and let's see what happens. So I should be able to put this to 0.2, but I'm going to make sure we have it working first. All right, looks like it was looking before. Let's do actually 0.1, because we don't need a lot of displacement for this sand. Or this gravel, sandy gravel, I guess we're using. And yeah, hopefully you can already see how helpful these are and how nice it'd be to work here. And say you wanted to mix a brick with a stone, you just alt drag to copy, and then probably in a minute or two even, you could set up the material. All right, so I can see now, and I'll stop it before it keeps going. Our noise does not have enough octaves, so this is a very smooth transition. And I actually had that. All right, it's really not liking this. Give it 1 second. I had the octaves on this back one here a little lower because I wanted a smoother cut between the sand and the rocks. But for this one, for a more worn and weathered look, I increased the octaves, which gave it more of a distorted and disturbed transition between the values of our noise. So let's see. Oops. Not that. I'm going to see if we have one of those saved. And I want this one. Color correct, and I'll just show you quickly here. So here, the octaves for this displacement was, I think, closer to 8, and this one was 3. So you can see the nice smooth here, and then this is a lot more distorted, with a lot more variation across the split between the materials. So X, and then let's increase our octaves to 8. Again, excuse my dog in the background. Karma XPU. And then we will give it just 1 second. see if it keeps going. And then, whoops, I want to get a different resolution, and this isn't what I was expecting. So I'm going to change the noise, and I want a more distorted noise. So let's see if we can fix that. I'm going to try CPU and see if this loads quicker. We can also decrease the size of what we're rendering by making this scene view a little smaller. And this probably won't work, but what I could do is turn off my dicing, which hopefully will speed up Karma XPU a little bit. We had our rest come in, our noise. Oh, maybe that's why. Yep, okay, that's why. So again, mistakes were made. It's a Perlin noise, which of course is going to have smoother transition values. I was looking to use a fractal noise. And now if I do this, hopefully I'll get the result a little bit closer to what I was expecting. We'll let it think. Could probably even increase the displacement on material too. There we go. All right, and now it's looking like it's a little bit off. So let me play with my remapping and see if I can get a value that has a better split between the rock and the sand. All right, this is really not liking this. I might have to restart. All right, welcome back. Just a quick restart, so hopefully we won't freeze again. I only changed actually this one thing here. This remap noise was on this side, I believe. I just slid it a little bit to this side to get it over here. And then what I'm also going to do is decrease the frequency of our noise, and then I'm going to bring our displacements back to a more equal value-ish, and then I'll adjust the global displacement. So let's render and see how this looks. Okay, there we go. We see a little bit of that. I might actually want to now scale our brick size down. So let's go to the adjust scale. We can do maybe 0.5. Still even a little smaller, maybe 0.3. And you could change this, doesn't have to be the same on the X, Y, and Z. If you wanted to distort your rocks or your bricks a little bit more, you're welcome to do that. So let's do this. I'm actually going to invert these because I want to flip the materials. Let's see if this works. It's usually not quite this slow, but we're rendering a lot and recording. There we go. And then let's scale our displacement on our rock wall down a little bit. And then there we go. Let's tint maybe a little bit the sand just to test that setup. Let's do this here, and maybe let's make it extra saturated too. And maybe our rocks would be a different color as well, just to test our setup. Maybe they are 1.5 saturation, and let's see what this gives us for hue. All right, there we go. So a quick setup for multiple materials, and now you can see our displacement is a little bit aggressive there, so maybe we could also adjust the offset on our displacement. Again, this was a subtract, so this should subtract 0.5 from our values and then bring them a little bit closer. And now in this case, our sand is being displaced at a different amount. So if we wanted to bring those back, maybe we could subtract a little bit more. So this is helpful if you want to displace different values at different amounts. And now I actually want to see these rocks back at the regular color, just because those are really looking nice. And one other thing actually I noticed here, right now we have a displacement intersection. So we're displacing the geometry so far that it is actually intersecting with itself on the back end of the ears. So if I zoom all the way in, we can see that it is being displaced, and that is an artifact there. So if your geometry is really thin and you're displacing a lot in the negative direction, you might displace back through itself. So to fix this, we could put our offset down to a smaller amount, which would subtract less from our displacement value and hopefully fix that issue. You could also measure the thickness of the object, store that as an attribute, and then inside here we could actually multiply our displacement by the thickness to make sure that never happens. And we might do that later, but that's going to be out of the scope for today's lesson. So there we go. We have our object, our material, triplanar mapping, and we will, one quick thing actually I'll cover really fast. We did a primvar reader and we typed mask and put that in here because we had painted those brush strokes on our material. What I would expect would be that mask to be represented in our blending. And there we go. So I just blended, so instead of using this noise as our mask from our rest position to a noise to remap, I took the mask value, which we painted with the attribute paint, and then I mapped that into here, and that is what is controlling our blend. So you can see how smooth that is. We could also add noises to these painting values, and we could do those in SOPs or even in materials. So I will let that continue to render out, and I'll actually show you where we painted that. Whoops, not in there. You to go up. We painted that right here with our attribute mask, or our attribute paint, and we painted an attribute named mask. All right, well, I'm going to stop that render, and then hopefully it won't freeze, but if it does, we will actually be right back to recap the whole lesson and then cover a few more quick things, and then that will be probably the majority of what we'll do today. So be right back in 1 second and we will keep going. All right, welcome back. I've just rendered out a quick preview and actually moved our pig head that we had, just arranged it a little bit better with the rest of our material spheres. So again, to recap kind of what we've set up just now, we have our new material, and I'm going to arrange some space. We set up a whole material blending system that let us blend between either a noise as the mask or a painted attribute, a custom attribute that we added here in our attribute paint, or with our attribute paint at the SOP level in the geometry. And we set up some global parameters for adjusting material 1 independently and material 2 independently, and then some settings for our displacement, some color correction for the entire material as a whole, and then some noise attributes that we set up for the actual mask between the two materials. So very useful and very common thing that I'd be doing a lot when working on projects is setting these up. And you could extend this, and we might do that in later videos actually, to add a metalness channel maybe. Maybe we would include some settings for metalness. Maybe we would add an option for emission or subsurface or even transmission. So this would be a general purpose material for rocks or objects or similar materials to what we have here. But if we did want to have maybe lots of glass in a shot, we might create a similar one of these with the transmission and subsurface and all those other effects that we would use for those type of materials. So we've covered a lot today. I hope you learned something new. You to go up and we'll recap just very quickly about all the material parameters we've covered. If you're new to 3D, then I'd recommend looking into these a little bit more. There's a lot you can do by understanding these and realizing where to apply them. And then as we continue with future projects on this channel, we will actually break down these from references and then apply our framework onto materials. So if we can find that framework again, right here, defining our goal, breaking it down, and then implementing that. So we could break down the materials for individual objects or for whole scenes and slowly build up these networks that we can reuse. So we did cover a lot today. Material properties, we learned about our attributes for multiple ones and even creating custom ones. With the mask, we did some textures with triplanar mapping and UV mapping. And then we covered some foundational knowledge on displacement, the settings of dicing, how that applies with tessellation, and then to our actual geometry that's displaced. We did review triplanars for the material projection and storing the rest position to sample later, which is a very, very handy trick we can do. And then we also learned a little bit about some procedural noises and how we can either use those to blend between materials or in the example of our metals. Let me show that real quick actually. I'm going to open up our map here, which is the same network, remember, and then jump into this. Whoops. ACEs. So this one here, we learned that our procedural materials can be used with noises, and we can use that to either mask certain parameters in our material or control the actual blending of different materials. So lots of flexibility there, and understanding how noises work and how to remap them and how to use them is a really powerful thing in Houdini, and we'll definitely be getting to that in later lessons as we continue to start applying some of this knowledge that we're actually learning. And then this blending of full materials that we did create with our master material. So we learned how to set this material up from scratch. We learned how to create this and then promote all the parameters into a handy, very user-friendly interface that we could use on our projects or share with other artists or use however we'd like. And again, you're welcome to use that in your projects. So very helpful stuff that we covered today, and I hope you guys again learned some new stuff. And if you did enjoy this, please do share the channel with other artists, and please subscribe for future videos because there's a lot more coming and we're just barely scratching the surface of what we can do in Houdini. So awesome. Thank you all for watching, and I hope you have a good one, and I'll see you in the next video.